Morning, everyone. Hope you're doing good. Okay. So, how's your event? How's your Ganesh Chaturthi event? Yeah, happy Vinayak Chaturthi. And especially for the Maharashtra people, because every year Ganesh Chaturthi used to do a lot of means a big festival. It used to be a big festival in Maharashtra, but this year, okay, fine, yeah. So in the previous class, we have discussed about the classification of slopes and water surface profiles. So let me give a quick review over here. I hope you will have gone through this PDF that I have shared with you. Okay. Now I hope my voice is clear. Does my voice is clear? Yeah. Give me a minute, please. Okay. Yes. Now, in the previous session, we discussed about something regarding to the classification of the slopes and water surface profiles. Okay. So for that, first of all, I have been derived this equation. What is this equation? Dynamic equation of the GVF, where dy by dx is equals to S naught minus SF by 1 minus FR square. And you know that S naught is nothing but channel bed slope. And whenever I say uniform flow, the S becomes S naught. And whenever I say the gradual evolved flow, S becomes S. You know the reason behind it, why I take that. And then for the wide rectangle channel, I took wide rectangle channel. I have modified the condition by using the Manning's equation. As I told you, Manning's equation can be used both in uniform flow and non-uniform flow. So from there, I got this equation, which dy by dx is equals to S naught into 1 minus yn by y whole to the power of 10 by 3 by 1 minus yc by whole to the whole cube. So from this, I can write that dy by dx is a function of whom? Yn and yc, comma y, where yn and yc for a given flow rate and bed slope, that is at two fixed depths of yn and yc, and for different flow rates means, so that different means the relation between yn and yc, yn may be more than yc, less than yc, or equals to yc, that is based upon the flow rate. So based upon those yn and yc, first we classified the slope as three slopes. Yn, if yn is going to be greater than yc, mild slope. If yn is equals to yc, critical slope. Yn less than yc, steep slope. Sir, how to find out yn? Sir, Manning's equation, sir. Because what is yn, sir? Uniform flow depth. What is yn? Uniform flow depth. So whenever I say uniform flow, the rest becomes S naught. How you are going to find out that? By using Manning's equation. And how to find yc, sir? You know already for rectangle, q square by g whole to the power of by 3. And for triangle, 2q square by g whole to the power of 1 by 2q square by gm square whole to the power of 1 by. So from there, we discussed about, can we use Chezy's equation? No. That's the reason why I told you, when if they do mention Chezy's, then only you find. Else you always go for the Manning's equation. Now, So from here, I have represented this mild and this mild and steep. So I represented the NDL. NDL means normal depth line, which represents the normal depth along the section, along the length of the channel. And CDL, YC along the length of the channel. Okay. So no matter whatever it is, whatever the slope you take, no matter whatever the slope you take, okay. Now you see, the entire flow medium is divided into three profiles. What are those profiles? Whenever the flow depth is going to be lies above NDL CDL, between NDL CDL, and below NDL and CDL. So based upon these conditions, I have given three profiles. The entire flow can be divided into three profiles. So the first profile is if flow depth lies above and above NDL and CDL. So always the first profile is a rising profile. And second profile, if flow depth lies between NDL and CDL, so the flow may goes between NDL and CDL. And third one, the flow may goes below NDL and CDL. So the second profile, you see, when the second profile you take, if flow depth lies below between NDL and CDL, it is always a drawdown. Whether you take a mild slope or you take a steep slope. Whether you take mild slope or steep slope, always second profiles are drawdown profiles. And now the third profile is going to be if flow depth lies below NDL and CDL, then always the third profile is going to be rising. So from this, I can say, the first profile and the third profile are always rising. The first profile and third profile are always rising. Second profile is always falling. That's it. Okay. So I hope you understood. Now, the biggest point is, yes, while it is rising, see, I'm saying you, listen, this is also a rising and this is also a rising. Yes or no? So both are rising curves only. Yes or no? This is also a falling and this is also going to be the falling. Both are falling curves only. But which one is going to be correct? I know that the first profiles are going to be rising. Rising means while it is going to be rises, should it rise like this or should it rise like this? So that depends upon the boundaries. That depends upon the boundaries. Look, I told you whenever the flow lies above NDL and CDL, then it is going to be first profile. Yes or no? Okay. What is the range of this first profile? Can you please tell me? What is the range of the first profile? See, the first profile means above NDL and CDL are none. So this one tends to infinity and tends to whom? Yn only, right? So what are the boundary conditions over here, my dear? Tell me please. What might be the boundary conditions of a flow here? The boundary conditions of a flow is the y can be infinity, y can be yn, y can be yc. See, for the second profile, what is the boundary? For the second profile, the boundary, what is second profile? When flow lies between NDL and CDL. So its boundaries are going to be NDL and CDL. So when y is equals to yn, what happens? When y is equals to yc, what happens? And then for the third profile, what is the boundary? CDL and bed. So now when y is equals to yc, what happens? And y is equals to 0, what happens? So now let's see about the boundaries. Once I know the boundaries, then I can state whether the rising is going to be convex or concave. Whether the rising is going to be convex or concave. You see, it may be convex or it may be concave. Yes or no? So now, in order to state whether it is a convex or concave, we need to study the boundaries. Let's start with the boundary. The boundaries means, so how many boundaries are there? Infinity, NDL, CDL, bed. Everywhere you take infinity, NDL, CDL, bed. Now, Okay. Coming to the boundary conditions. Coming to the boundary conditions. So in the case of the boundary conditions, what happens? Number one, when y is equals to yn, what is going to be happen? Remember, when y is equals to yn, what is meaning of one y is equals to yn? What is the meaning of when flow depth becomes normal depth? Then it is uniform flow, right? Whenever the flow is uniform, when you say the flow is going to be uniform, when dou y by dou s is equals to 0. Yes or no? What is the meaning of dou y by dou s? Variation of the depth with respect to length. When y is equals to yn, uniform flow, and then dou y by dou s or dy by dx is going to be 0. Yes or no? But now check with this. You know, right? You know this equation, right? So in this equation, can you please tell me what happens when y is equals to yn? If y is equals to yn, my dear, if I keep y as yn, then you tell me. If I keep y as yn by yn, 1, 1 to the power of anything, 1, 1 minus 1, 0. Yn by y as yn by yn, 1, 1 minus 1, 0, right? Then the dy by dx is equals to 0. What is the meaning of dy by dx is equals to 0? The meaning of dy by dx is equals to 0 means, what is the meaning of this yn? So if I take this as an MDL, whatever this line is going to be the MDL. Okay. So now when the flow is going to be happen, the flow depth is also going to be MDL. Now the flow depth is also going to be MDL. What is the meaning of dy by dx is equals to 0? So now whatever the water level that is going to be rises, see that slope along the x, this is x, right? Along the channel bed, that dy by dx is equals to 0. What is the meaning of dy by dx 0? This is a plane. If the graph flows like this, then is there any slope over here? No. Dy by dx is equals to 0. Dy by dx 0 means there is no change in the vertical magnitude. Yes, sir. You can observe here once again. Yes, there is no change in the vertical magnitude. Yes or no? Because it's parallel to the NDL. When parallel to the NDL, there is no slope. And now, from here onwards, the flow may rise like this. You see, this is a water surface. From here onwards, the flow may fall like this. You see, whatever this zone, my dear, if you please observe, whatever this zone where y is equals to yn. So when y is equals to yn, then in this zone, if you observe over here, the water level is going to be asymptotic to NDL. It asymptotic means it seems to be touching. From here only everything is going to be start. From the NDL only everything is going to be start. Okay. Asymptotic to. So here for the NDL, the dy by dx is equal to 0, which means the variation of the water surface with respect to NDL, the variation of the water surface with respect to NDL, when y is equals to yn, it is 0, which means it is going to be asymptotic to NDL. Asymptotic means almost parallel, my dear. Asymptotic to NDL. So I can write flow is asymptotic to NDL. So whenever the flow is going to be goes from the NDL, means whether it is rising from the NDL, it should be rises asymptotically. It should be falling asymptotically to the NDL. Okay. So if there is an NDL and for that NDL, I have to make sure it should be always asymptotic. Okay. Now, Let's see what is the other boundary. We are taking y greater than yn, y less than yn, and y greater than yc and y less than yc. Now I am taking the other boundary is going to be y is equals to yc. Y is equals to yc. What happens when y is equals to yc? Now go back. You see, my dear, this one. When y becomes yc, when y becomes yc, what is the meaning of y becomes yc? Yc by yc, 1. 1 minus 1, 0. Anything by 0, anything by 0, then dy by dx is equals to infinity. What is meant by dy by dx, my dear? The dy by dx is nothing but tan theta. The dy by dx is nothing but tan theta. Yes or no? So the meaning of tan theta is equals to infinity means when theta is equals to 90 degrees only, right? Yes or no? So now you see, if this is a CDL, means critical depth line, when the flow is going to be meets the CDL, when the flow is going to be meets the CDL, its angle dy by dx is equals to infinity. Literally, it is going to be infinity. The meaning of infinity means perpendicular. So when the flow is going to be parallel, then slope is 0. When the flow meets are perpendicular, then the slope, see what is the slope? The slope is going to be 90 degrees. Which means if the flow comes over here, it meets perpendicular. It meets perpendicular. So whatever this angle is equals to 90 degrees. Perpendicular. Similarly, whenever the flow is going to be, see, this is a falling, right? Falling towards CDL. And whenever the flow is going to be rising also, you see, at this point, I am drawing a two dotted lines to represent the perpendicularity to the CDL, my dear, to the CDL. So this is also going to be 90 degrees, and this is also a water surface. So either the water surface may rise or may fall. Keep that in your mind. It may rise or it may fall, and you know where it is going to be rise, where it is going to be fall. So when it is touching the NDL, it should be asymptotic. You observe here. When it is touching the NDL, it should be asymptotic. And when it is touching the CDL, it should be perpendicular. When it is touching the CDL, it should be perpendicular. So now I can say flow meets perpendicular to CDL. So this is our two boundary conditions over here. And now when yn is equals to y is equals to yn and y is equals to yc, I said you y equals to yc, y equals to yn, I said. Now what are the other two boundaries? Infinity and when y is equals to 0. Still, is there any voice problem? Still, is there any problem, voice problem? Okay, fine. Yeah. So now let's see. So now let's see the next one. The next one is next boundary condition. When y is equals to infinity, what is dy by dx? When y is equals to infinity, what is the dy by dx? Now, everybody have a look. See, I am using this equation only. I am using this equation only. Now, when y is equals to infinity, what is going to be happening, my dear? If I keep y as infinity, then 1 by infinity is equals to 0. Yes or no? So yn by infinity is 0. 0 for anything, 0. 1 minus 0, 1. 1 minus 0, 1. Okay. Now, yc by y. Y is equals to infinity when yc by infinity, 1 by anything by infinity, 0. So 1 minus 0, 1. So numerator s naught into 1, denominator is also going to be 1. So what is the dy by dx now? That dy by dx is equals to s naught. The dy by dx is equals to s naught. I hope you understood. So what is mean by dy by dx is equals to s naught? What is the meaning of dy by dx is going to be s naught? You see, yes. So you know this is a channel bed, and whatever the slope of the channel bed with respect to horizontal, this is nothing but s naught. And you know what is the meaning of dy by dx? You know this is x-axis, right? That's what I said in the case of the derivation of the GVF. Okay. So now what is the meaning of dy by dx is equals to s naught? See, if the flow is going to be like this, if the flow is going to be like this, yes. Now you know what is the variation of the water surface? This is going to be the dy by dx. What is mean by dy by dx, my dear? Dy by dx means when the variation of water level with respect to x-axis. So now this is going to be dy by dx. When both are going to be same, when dy by dx is going to be same, when the water surface is going to be exactly horizontally. So this S naught is with respect to horizontal or not? So now, how does this water surface is looking like? Is it horizontal or inclined or vertical or asymptotic? This is going to be asymptotical to horizontal. Asymptotical to horizontal, which means whenever the maximum flow depth is going to be there, if the water level is going to be rising, my dear, it rises and becomes a constant, which means what is the meaning of here? Asymptotical to horizontal. Asymptotical to horizontal. Now, the last one, y is equals to 0. Remember, what is the meaning of y is equals to 0? What is the meaning of y is equals to 0? There is no flow, right? When y is equals to 0, then there is no flow, not possible. No flow or undefined. When y0 means no flow depth, right? So now I hope you understood what are these boundary conditions. When y is equals to yn and when y is equals to yc, and then when y is equals to infinity. So by using these points, one is flow is asymptotic to NDL. Whenever the flow meets NDL, it should meet asymptotical. Whenever the flow meets CDL, it should meet perpendicular. Whenever the flow meets infinity, it is going to be horizontal. Okay. Now, let's take the mild slope and I'll explain all these things. Let's take the mild slope. So, have a look, my dear. Mild slope means the bed slope is very less. And in the case of the mild slope, you know, the NDL is going to be more than the CDL. Whatever this dotted line, this will represent as a CDL. And on the top of it, whatever, see why I am drawing this as a dotted line, sir. Sir, we are discussing about the GVF. Okay. We are discussing about the GVF. And in order to define the GVF, I am taking the NDL and CDL as some reference lines. That is the reason why I am taking this one as a C. This is CDL. And here it is going to be NDL. Okay. Now, question number 1 for you. What is the first profile? Listen and tell me. What is the first profile? Always first profile is a rising or falling profile? Rising. Yes. Keep that in your mind. It is going to be a rising profile. Okay. So when it is going to be a rising profile, now, when it is going to be a rising profile, and see this rising profile means this is the first profile, right? And from where the flow is going to be starts NDL. Yes or no? Because for the first profile, what is the boundary? Yn, and what is the other boundary? Infinity. Okay. Yn and infinity. See, don't think that the profile is going to be comes from second profile to first profile. No. If I say first profile, whatever above NDL, CDL, that is going to be the first profile. And what is the boundary here? NDL. And what is the other boundary? Infinity. So flow is going to be happen in this zone only. And now my question is whether the flow comes like this or like this. Yes. So now the biggest one here is now the biggest one here is, so now you need to know okay, now you need to know. So when the flow is going to be start, if it is a first profile, if it is a first profile, when do you use a first profile? If the depth, the flow depth is lying above NDL and CDL. Okay. If the flow depth lies above NDL and CDL, we say it as a first profile. Okay. So now you see this is NDL and flow is going to be meets first NDL and then towards the infinity. So just now I said whenever the flow meets NDL, is it going to be asymptotical to NDL or perpendicular to NDL? Asymptotic. So the boundary of the NDL, so the boundary of the first profile is NDL. So the flow is going to be starts NDL, asymptotical to the NDL. And is it rising or falling? Rising. Is it rising or falling? Rising. So rises, rises, rises. And when it is going to be end, the end means y is equals to infinity. We don't know what is that. So it is going to be asymptotical to horizontal. It is going to be asymptotical to horizontal. You please observe, this is the horizontal and this is a horizontal. Whenever the depth of flow depth is going to be infinity, keep that in your mind, my dear, then the flow is going to be a horizontal. So flow starts asymptotical to NDL. Flow starts asymptotical to NDL. Observe, flow starts asymptotical to NDL, rises, and when it is going to be end, it is going to be horizontal. It is going to be horizontal. This is the first profile. This is the first profile. Can I say does this profile is exactly looks like whatever the flow curve I have given on the back of the obstruction? On the back of the obstruction. Have you remembered that? On the back of the obstruction. I hope you remember. What is this? This is going to be asymptotical to NDL because this is uniform here, right? Asymptotical to NDL rises, and then see by the time it reaches the maximum, it is going to be horizontal, right? So why I have drawn this curve over here like this? This is nothing but a concave. Whatever the shape, sorry, whatever the shape, in the case of the, let me draw this once again. In the case of the first profile, whatever the shape is there, right? So that shape you can observe. You can observe first asymptotic, convex, asymptotic, convex, rises, and it is going to be horizontal. You can see there is a convexity and there is a concavity. There is a convex and there is a concave. So here the flow is going to be made first asymptotic to NDL and then finally it is going to be horizontal. Now as it is a mild slope and moreover this is the first profile, now I am going to say this one as M1. What is M1? Mild slope first profile. Mild slope first profile. Okay, I hope you understood this. Now let's come to the next part. Now let's come to next one. In the case of the next second profile, my dear. In the case of the second profile, have a look. See, second profile is always falling or rising. Come on, tell me. Second profile is always falling, my dear. Second profile is always falling. Second profile is always falling means, is it happening between NDL and CDLS? Yes. Is it falling or rising? Falling. Falling from whom? See, when I say rising, rising from NDL to infinity. Now it is falling, right? Falling. Falling from whom? NDL. Towards whom? CDL. When the flow is falling from the NDL, asymptotical to NDL, keep that in your mind. This is asymptotical to NDL and perpendicular to CDL. Asymptotical to NDL and perpendicular to CDL. See, at the end, I am going to represent two dotted lines. So, asymptotical to NDL and perpendicular to CDL. In reality, if there is a drawdown profile in the mild slope, how come you say this is mild slope, sir? When yn is greater than yc, then you can say it as a mild slope. So now this profile is known as M2 profile. This profile is known as M2 profile. See, I am keeping only two conclusions in my mind. Conclusion number one, always flow, always first profile and third profiles are rising profiles. Always first and third are rising and second one is a falling. Always first and third are rising and second one is going to be falling. Okay. And second conclusion is always when the flow happens, flow is asymptotical to NDL. I hope you can understand now what is the meaning of asymptotical. You please observe in this zone. I have explained the same thing or not? Asymptotical to NDL and perpendicular to CDL. And perpendicular to CDL. Okay. Now coming to the next one, third profile. What is the third profile, my dear? Third profile means rising. Okay. So when it is rising, it should rise like this. Yes or no? From where to where it should rise? Please. From where to where? From y0 to y is equals to CDL. From what is the boundary between the third profile here? 0 and CDL. And now just now I said you. When y0, no flow condition, so undefined, my dear. Undefined means now, observe, for the undefined, what I am going to do is line, dot. So the meaning of the line, dot means it is going to be undefined. So up to that point, it is going to be undefined. Now, but you know that the flow should meet asymptotical or perpendicular to CDL. It should meet perpendicular to the CDL. So as it should meet perpendicular to the CDL, now line dot. So the flow is going to be rises. Is it rising or falling? Rising. Rises. And is it going to be asymptotical to CDL or perpendicular to CDL? Asymptotical or perpendicular? Perpendicular. So now this profile is M3. Sir, why you have drawn perpendiculars are here? Because it is a CDL. Why I have drawn perpendicular here? Because the flow is meeting CDL. And why is asymptotical over here? Because it is meeting NDL. Why it is horizontal here? Because when y is equals to infinity, dy by dx is s naught, which is asymptotical to horizontal. This is s naught, right? Yes. And when y0, no flow, so line dot line. Okay. This is how in reality the flow looks like. Now the question is, do you think all the three flows are going to be exist at a particular section? Do you think all the three flows are going to be exist in a particular section? No. If the flow is going to be rising, if it is M1 profile, it should look like this. And when the flow is falling, M2 profile. And when it is going to be again rising, it is going to be M3 profile. Okay. So along the length of the section, you can see these profiles. You cannot see this profile at a particular section. So rises, falls. Do you think does these profiles are going to be seen at a particular section? No. At a particular section, only one profile is going to be seen. So M1, M2, M3, always first and third profiles are rising profiles. Second profile is falling profile. And while it is rising, if it is rising from NDL, then it is going to be asymptotic to NDL. Falling from NDL, asymptotic to NDL. And rising to CDL, asymptotic perpendicular to CDL. Falling to CDL, perpendicular to CDL. I hope you understood. If you have understood this, now let's see what happens in the case of a steep slope also. For any condition of flow, the flow will be meeting NDL asymptotic, CDL perpendicular. Sir, why first and third always rising profiles? Sir, have you attended the previous class? Whoever asked this question, have you attended the previous class? If you have attended the previous class, I have given the example, means I have given the reason behind it, why first and third profiles are rising. You see, first profile dy by dx positive. See, without going through the previous class, if you really want to come to the class, I'm telling you again, I don't know what is happening with the other class, but I said the same things in Geotech also. If you want to come to the next class, you please be prepared with the previous class. See, whatever the 2.5 hour session I used to take in weekdays, that you can revise in 15 to 20 minutes. If you don't spend that time also, I'm telling you, it won't be a piece of cake for you. So if you are going to be studying with the previous classes, then it will be very easy to follow the next classes, right? And that is going to be applicable for all the subjects, my dear. Okay. Now, here, so let's see the regarding things and remaining things. So M3 is not 0. When y is equal to 0, means when y is 0, what is the meaning of y0? At that point, see, when the flow is happening, it comes from 0 to, right? So that is the reason why at the starting, I cannot define that. At the starting, I cannot define whether it is a perpendicular to bed or parallel to bed. So when the flow is going to be rising, it is going to be perpendicular to bed, I cannot say, or parallel to bed, I cannot say. So that's the reason why I'm showing M3 away from the bed. Away from the bed. Wait for a moment. I'm going to discuss about the practical scenarios. I'll be discussing about the practical scenario. Don't worry about that. No. Practical examples. Scenario. Okay. Back of an obstruction or pool of water okay, fine. Back of an obstruction, just to keep it. So that obstruction may be weir or barrage are done. So I am discussing about for the mild slope, right? For the mild slope. Okay. So for the mild slope, I am giving you this is for the M1 profile. For the M1 profile, where do you observe this one is on the back of an obstruction. Have a look, my dear. So I am giving you the mild slope. Okay. So let's go back to the this is a slope, mild slope, and this is a serial, and you're pretty sure what about this? This line is going to be the NDL. Now there is an obstruction over here. There is an obstruction over here. So whatever is nothing but a weir or a barrage like this. Okay. There's an obstruction. Now what is going to be happen? So whatever the slope I am giving you here, the slope is going to be a mild slope, my dear. The slope is going to be a mild slope. Okay. So now keep that in your mind. Here, in the case of the mild slope, how the flow is going to be happen? How the flow is going to be happen? So you see, in this case, you observe always away from the obstruction, the flow is going to be uniform flow. Away from the obstruction, the flow is going to be uniform flow. I told you clearly when I classify the flow. You please remember, away from the obstruction on the upstream side and the downstream side, always flow is uniform. Always flow is uniform flow. Okay. So now, as it is going to be the uniform flow, my dear, you observe here, this is going to be uniform flow. And when this water level hits the obstruction, the water level is going to be rises. Yes, sir. When the water level is going to be rises, is it rising profile or falling profile? Rising. And now it is going to be asymptotical to NDL. See, up to this point, the flow is going to be uniform. Up to this point, the flow is going to be uniform. From here onwards, asymptotical to NDL, rises, rises. And when it reaches the maximum water level at the gate, it is going to be asymptotical to horizontal. What is this profile, my dear, here? This profile is nothing but M1 profile. On the back of an obstruction, which profile is going to be forming? M1. And you know that the flow is going to be asymptotical to NDL and asymptotical to horizontal. I hope you understood what is the meaning of M1 profile. So in this case, you are observing the profile as M1 profile. Okay. Now you tell me, please, does M1 profile is going to be a subcritical flow or supercritical flow? Come on, tell me. Whatever this depth, you know that. Whatever this depth, this is YC. This is YC and this is YM. Yes or no? So now this is YC. Whenever the flow depth is going to be above YC, whenever the flow depth is going to be above YC, means above CDL, the flow is going to be subcritical flow. So I can say the M1 profile is a subcritical. I can say the M1 profile is going to be subcritical. And now I am coming to the M2. See, M2 is also going to be above CDL or why I am taking this as subcritical, right? So M2 is also going to be subcritical. Now, because as M2 is above CDL or below CDL, as long as Y greater than YC, then it is going to be subcritical flow. Y less than YC, that is going to be supercritical flow. So whatever the water level above, if I say the depth is going to be here, y is greater than yc, then still this is going to be the subcritical. Look, these are very, 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 very important conditions. You are going to see a lot of questions in the ESC based upon this. And what about here? This is going to be supercritical. So you need to understand the concept clearly. So far and so good, I told you two basic conclusions. One is first and third are rising. Second one is falling profile. Second one is always the flow is asymptotical to DL and perpendicular to CDL. Now let's see the example for the second profile. So second one is sudden drop in canal bed. Sudden drop in the canal bed. Again, this is a canal. And you know, this is going to be CDL. And here, once again, it is going to be NDL. See now, what is the help of this NDL and CDL is, it will help you that where the flow is happening, it will confine the boundaries. Okay. Now, whenever there is a sudden drop in the canal bed, so what is the meaning of sudden drop, sir? See, as long as the channel is like this, right, the flow is going to be uniform. Can I say like that? As long as the channel is like that, the flow is going to be uniform. What is the meaning of uniform flow? The y is equals to yn. I hope you understood what is the meaning of the uniform flow. Y is equals to yn. Yes. Now, if there is a sudden drop in the canal bed like this, this is a sudden drop in the canal bed. What may happen, sir? If there is a sudden drop in the canal bed, then suddenly the water level should fall or not? Yes. While it is falling, what is the shape it should take? Now, okay, sir, falling. Falling means, is it a second profile or third profile? Second profile. Now, when it is a second profile, it should meet, means in the case of the mild slope, if it is a second profile, it should meet asymptotical to DL. Now, can you tell me, do you think, sir, water level falls like this? Do you think water level falls like this? Let's see. Okay, fine. This is second profile. Fine. But what about this one? This is third profile. Do you think the flow will enter from the second profile to third profile directly like that? Do you think the flow will meet directly from the second profile to the third profile? And what is the third profile? Does the third profile is rising or falling? Rising. Second profile is falling. Third profile is rising. See, but if I draw the graph like this, right? If I draw the graph like this, then you see in the third profile, is it falling or rising? Falling. Is it possible? No. Which means, though it is falling, it should not fall like this. Though it is falling, it should not fall like this. Yes. And when it is a falling, now you observe over here. When it is falling, it should not enter into the third profile because always the falling profile is the second profile. So whenever there is a drop, then the water level is going to be fall asymptotical to NDL and then perpendicular to CDL like this. And then perpendicular to CDL like this, and then it reaches the water level. So this is the water level. Okay. So whatever this profile, this is going to be the M2 profile. I hope you understood why I have represented this one. See, I did not draw the graph like this. Did I? No. Why? Because this is also falling, this is also falling. But the falling is only second profile, my dear. And the second profile lies between whom? NDL and CDL. Okay. So flow will not fall below CDL, because below CDL it is not a second profile, it is a third profile. Third profile is rising. So this is not going to be possible. The variation is going to be like this. Is M2 profile. Wherever you see the flow falls like this is going to be the M2 profile. So now you say here there is a convex and here there is a concave. And this is concave. And here it is convex. We just simply know that one point. We just simply say whatever if the curve looks like this. If the curve looks like this is going to be concave, and if the curve looks like this is going to be convex. Okay, so this is concave, and it is going to be convex. So now you see M2 is going to be concave or convex? Concave. But M1 is going to be having convex and then concave. M1 has both the convex and concave. This is M2. Now similarly, where do you see the M3 profile, sir? Where do you see the M3 profile, sir? Where do you see the M3 profile is entry of flow through sluice gate. See, these practical examples are very, very important. Entry of a flow through a sluice gate or on the downstream side of an obstruction, or on the downstream side of an obstruction. Now again, whatever, this is nothing but serial. What about here? This is going to be the, this is very, very interesting condition, my dear. You please have a look about this. So here, this is a sluice gate. So whatever, this is nothing but a sluice gate. And here this is the channel bed. How does the flow is going to be takes place on the downstream of a sluice gate? Whatever, this is nothing but a sluice gate, right? Okay. So what is happening on the downstream? You look over the downstream entry of the flow through the sluice gate. Okay. So first of all, my dear, due to this due to this end contraction, I can say the end is going to be looks like this arm. So due to this end, what happens is when the flow is entering into the downstream side, first due to this end contraction, what happens is the water level will fall and reaches the vena contracta. You see, I hope you remember the meaning of vena contracta. First, water level will fall and immediately reaches the vena contracta. Immediately reaches the vena contracta. What is vena contracta, sir? Vena contracta is a section where the area will be minimum. Whenever you see, you can observe this one. So in your home, if you have water can, if you have a water can, you just pour the water through the water can, not by tapping it, you just pour it. When you allow that water, it is coming from a opening. Yes, while it is coming from the opening, when you pour it, or when you pour a bottle of water, initially the flow jet area is going to be decreases. Initially, the flow jet area will decreases and reaches a minimum known as vena contracta. And from there, the flow jet is going to be formed. Yes or no? You just observe that. If you have never observed that, you came across the vena contracta. So vena contracta is a section where the flow area is minimum. This is the vena contracta, my dear. And now, what about here? What about here? This is NDL. Here, CDL. Now, I want to say, I will clear you one point clear here is 1, 2, 3, 4, 5. I hope you remember this figure. I hope you remember this figure. See, before the start of the flow, what is the flow? Uniform flow. At the end, what is the flow? Uniform flow. Before uniform flow, after uniform flow. Before uniform flow, after uniform flow. Which means before the flow, this is NDL. After, this is going to be the NDL. Can I say one point? No matter whatever the obstruction it is, no matter whatever the obstruction it is, always on the upstream side, flow starts with NDL. Always on the upstream side, flow starts with NDL. And always on the downstream side, flow ends with the NDL. Which means, my dear students, no matter whatever you take, on the start of a flow, it should be uniform, means NDL. On the end of a flow, it should reach again NDL. So the third conclusion, flow always starts with NDL and ends with NDL. Whatever happening in between, I don't care. In between, it may rise above NDL, falls below NDL, or in between, or it may touches NDL, I don't care. But when the flow is going to be started, it always starts with uniform flow, means NDL. And it always meets the uniform flow at the end. It's also going to be uniform flow, means NDL on the downstream side. So by using this point, yes. By using this point, see, now here this is NDL. Listen to the point clearly. Listen to me clearly. Just now I mentioned that flow. You see, in both the cases also, this is upstream, flow starts with NDL. This is upstream, flow starts with NDL. Now, this is the downstream side, flow should end with NDL. Always flow start and ends with the NDL. Now I have to meet here, my dear. Okay, think and say. When I have to rise over here, then definitely it should, when I have to meet NDL, it should rise or not? Yes. Now, which zone it is? Third zone. And third zone is rising or falling? Rising. Third zone is rising or falling? Rising. I want to meet whom? NDL. I want to meet whom? NDL. So now it is a third profile. In the third profile, the water level is going to be rises. And while it is rising, it is going to be rises perpendicular to CDL or parallel to CDL? Perpendicular to CDL. Perpendicular to CDL. Now, some of the students have asked me, Arista, why you have represented the M3 profile as a dot line? Here we don't know where the flow is going to be started. Now you can see in practically the flow is going to be start from here. That is the reason why I did not discuss anything regarding to this zone. Okay. So now what is this profile? This is M3 profile. This is M3 profile. Now I want to write one more point. See, this is CDL. Above CDL, it is a supercritical, subcritical flow. And below CDL, this is going to be the supercritical flow. Now, the interesting point is, okay, this is M3. Listen, this is M3, rising or falling? Rising. But I want to reach whom? NDL. But I have reached up to whom? CDL only. Now, in order to rise further, keep that in your mind, in order to rise further. Now, what is this profile? This is second profile or third profile? This is second profile or third profile? Second profile. And what is the nature of the second profile? Rising or falling? Rising or falling? Falling. But I want rise. You see now, I want to rise. But the nature of the second profile is going to be to fall. I want to rise, but the nature of the second profile is going to be to fall. I want to rise, but the nature is going to be fall. So it is going to be create a reverse flow known as hydraulic jump. It is going to be create a reverse flow known as hydraulic jump. So let me repeat that again. See, I want to meet whom? NDL, because the final after the flow that disturbances, it should meet NDL because it should be uniform. So I want to rise to NDL, but the nature of the flow is going to be CDL. The nature of the flow is going to be whom? Second profile, right? So it should be CDL, means it should have fall down. So I want to rise, but the nature of the second profile is going to be falling. I want to rise, and the nature of the second profile is going to be falling. So then the hydraulic jump is going to be created. This is the reason why I said, now you see what is the basic condition of the hydraulic jump? When the supercritical flow meets the subcritical flow. See, whenever the flow is meeting the flow below the CDL meets the flow above the CDL, then it is going to be the hydraulic jump. And once it happens, now finally, the flow will reaches the NDL. So you can see the reverse flow happens. You can see there is a reverse flow here. You can see there is a reverse flow. So due to this reverse flow, hydraulic jump is going to be created, and then the flow is going to be reaches the NDL. And then the flow reaches the NDL asymptotically. So this is how it should happen. Now, I hope you got the points over here. This is NDL. So after some time, it reaches to the NDL. Whatever, this is nothing but hydraulic jump. So why the hydraulic jump is happening? Whenever the flow meets from supercritical flow to subcritical flow, then there is a hydraulic jump. So I want to meet whom? NDL. But what is happening over here? I want to meet NDL up to CDL. Please have it. So the last time I'm repeating this because a lot of people are asking again. So can you please repeat again? Okay, fine. Yeah. So now you know that at first, see, I want to reach the NDL because at the end the flow should meet the NDL. Flow should start with NDL, ends with NDL. So now I want to meet the NDL. So it should rise. As it is a third profile, it is going to be rises. As it is a third profile, it is going to be rises perpendicular to the CDL. And now from here onwards, it is going to be dotted. Yes, sir. By the time it reaches the CDL, it is rising. But now you observe, I want to reach whom? NDL. If I want to reach NDL, I have to rise further. I have to rise further. When I rise further, then I am going to enter into which profile? Second profile. When I rise further, I am going to enter into second profile. Now, what is the nature of the second profile? Falling or rising? What is the nature of second profile? Falling or rising? Falling. But I want to rise, but the nature of the second profile is going to be fall. So it will create a hydraulic jump like this. It will create a hydraulic jump like this. And after the hydraulic jump, then it reaches to the MDL. So why we say the hydraulic jump occurs when flow meets from super to subcritical is when the flow is meeting from super to subcritical, it is changing from third profile to second profile. When the flow is meeting from the supercritical to subcritical, the flow is changing from third profile to second profile. The nature of third profile is rising, the nature of second profile is falling. So I want to rise, the nature is going to be fall. So I want to rise, nature fall. I want to rise, nature fall. I want to rise, nature fall. It is going to be create a reverse of flow that is known as hydraulic jump. Is known as hydraulic jump. So I hope you understood what is the meaning of hydraulic jump here. And whatever the profile over here, this profile is nothing but M3. Keep that in your mind. Here, M3 followed by hydraulic jump. M3 followed by hydraulic jump. So why the hydraulic jump is going to be happen over here only is because it is going to be meeting from super to subcritical. I hope you understood this. Sir, why you not show flow touching bed in M3 profile? Sir, how come it is going to be touches the bed, sir? Please tell me. Sir, is this there gate? Is this there for gate? Yes, it is there. Lord Krishna make bed touches, sir. Okay, sir. You ask Lord Krishna to teach open channel. So I hope you able to understand. See, what if I would have been lift the sluice gate above the CDL? If I would have lift the sluice gate above CDL, then there is no hydraulic jump. If I would have lift the sluice gate up to this point, then there is no hydraulic jump. Then directly flow will enter into the second profile. So such a type of case is not going to be possible. Keep that in your mind. That is the reason why we always lift the sluice gate below CDL only. Now, similarly, let's go with the steep. Let's go with the steep slope. So I hope you understood what is happening in a mild slope, M1, M2, and now this is an M3. So let's go with the steep slope. Now, this is a steep slope. And you know, in the case of the steep slope, when do you say steep slope? When do you say steep slope? When NDL means when YN less than YC, which means NDL is below the CDL. When NDL is going to be below the CDL. Okay. So when do you say steep? When YN less than YC. So that is the reason why. What is this? This is CDL. What about here? Here it is going to be NDL. And what about this one? This is going to be the bed. So come on, my dear. Let me discuss this. See, this is a convex or concave. This is convex, my dear. M3 is convex. M3 is convex. So now you see, so in the case of the serial and means in the case of the steep slope, again come to first profile. You know the basic concept. First profile and third profile, whatever the slope it is, first profile and third profile are always rising. Second profile is always falling. First profile and second profile is first and third always rising. Second one is always falling. Okay, that's I know. And second point is when the flow is happening, that flow must meet asymptotical to NDL and perpendicular to serial. Now, this is the first profile, right? This is the first profile. And what is the infinity here? And what is the starting point? Serial. So now the first profile is starting from serial to infinity. Yes or no? First profile is starting from serial to infinity. But you know, flow always means perpendicular to serial or asymptotic to serial. Perpendicular to serial. So now you see perpendicular. Perpendicular to serial. And finally it is going to be horizontal or not? Finally it is going to be horizontal. So at infinity it is going to be the flow water level is going to be horizontal. At infinity water level is going to be horizontal. And at a starting point, you know the flow is going to be asymptotic to serial or perpendicular to serial. It is going to be perpendicular to serial. It is going to be perpendicular to serial. So I can say this curve as a S1 profile. Is it a convex or concave? Simply convex. It is going to be convex. Similarly, now coming to the S2. What is S2? Falling. Falling from whom? Serial to meeting whom? NDL. When the flow is going to be falling, it is going to be second profile. Now, while it is falling from the serial, perpendicular to the serial, and then it is going to be asymptotical to NDL. And then it is going to be asymptotical to NDL. See, whenever it reaches the NDL, then it is going to be uniform flow again. Keep that in your mind. When it reaches the NDL, then the flow is going to be uniform. So that's the reason why I'm not touching the NDL. Have you observed that? Am I touching the NDL? No. The GBF is asymptotical to NDL. And now when the GBF touches NDL, it is no more GBF. Because when flow touches NDL, that is a uniform. So what is this profile? This is going to be S2 profile. Sir, why I have drawn this S2 profile like this, sir? Because the CDL and NDL. Now flow is meeting from serial, falling, right? Meeting from serial to the NDL. Similarly, last one, at the bed, I cannot say that. So line dot line, line dot line. And it is going to be NDL or CDL? NDL. Rising or falling? Rising. So when it is going to be rising, rises, rises, and now it is going to be asymptotical to NDL. Asymptotical to NDL. So this is going to be S3. You observe all the three graphs, so S1 and S3 are rising, S2 is falling. But you see what is the difference between the curves? What is the difference between the curves? Earlier I explained the curves like this, especially you observe M2. In the case of the M2, in the case of the M2, that is going to be concave. And now in the case of the S2, that's going to be convex, right? S2 convex and M2 concave. So the flow can be either convex or concave, depends upon whom? Boundaries. If it is falling from NDL to serial, NDL is asymptotic, serial is perpendicular. But in the case of the S2, flow is falling from serial to NDL. So perpendicular to serial and asymptotic to NDL. Similarly, in the case of the mild M1, flow starts with NDL, means asymptotical to NDL and infinity horizontal. But in the case of the S1, flow starts with serial here, means In the first profile, I'm telling you, in the first profile. So asymptote perpendicular to CDL and horizontal asymptote. So similarly, in the CDL, M3 flow ends with the CDL perpendicular, S3 flow ends with the NDL asymptotic. I hope you understood the S1, S2, S3. So same thing, I'll be explaining the see why are you asking again me like sir whether S1 is going to be convex or concave? You know the shapes, right? You know the shapes, right? That's a concave. That's concave. Now let's come to the practical situations for the steep. For steep. So now coming to the S1 profile, I'll take the same examples. I'll take the same examples and I'll make sure you understood the pool of water ended by an obstruction. Pool of water ended by an obstruction. Okay. So now you see. This is a steep slope. It is going to be the NDL. Here it goes to the CDL. And there is an obstruction here. There is an obstruction over here. So now this time it's no more mild, it's a steep. It's a steep slope. So this is NDL and here it is going to be the CDL. Okay. Now my dear, have observed here. You know that in practically flow always starts with the NDL and meets NDL at the end. Yes, flow starts with the NDL. Practically, flow is going to be starts with uniform flow. Because see, if there is no obstruction, come on, tell me. If there is no obstruction, if there was no obstruction, the flow was uniform. Yes or no? If there was no obstruction, the flow was uniform. But now, due to obstruction, you know, when the water hits the obstruction, the water level is going to be rises. Accept or not? When the water is going to be hits the obstruction, the water is going to be rises, which means it is going to be rising profile. Yes or no? So on the back of an obstruction, always the water level is going to be rising. So it should rise like this. But how come it is going to be rises? Think and see. See, this is a gate. How come it is going to be rises? Think and see. That's what I want to know. Now, everybody understand here clearly. Okay. So I want to rise up to this point. I want to rise up to this point, but the NDL is over here. Just now I explained the M3 profile, right? I want to rise up to this point, but I am here. Okay. So now this is the first profile. This is the second profile zones. But if I want to move here, I have to cross the serial. Yes or no? I have to cross the serial. Yes or no? Yes. And you know, above serial, this is a subcritical flow, and below serial, this is a supercritical flow. Whenever the flow meets from sub to super, whenever the flow meets from super to sub, then the hydraulic jump is going to be happening. Now, you see, I want to rise up to this position. Now, let's come to the, I want to rise I want to rise, but this is second profile or not. I want to rise, but second profile falls. So hydraulic jump is going to be formed. Once the hydraulic jump occurs, now it is in which profile? First profile, and then the flow is going to be rise like this. Now you see carefully. First, there is a hydraulic jump like this. Yes, and then the flow is going to be rises asymptotic to horizontal like this. Sir, why there is a hydraulic jump over here, sir? Because the supercritical flow is meeting whom? Subcritical flow. So this is a starting NTL from here. So that's the reason why you see I have provided a dot over here, right? What is the provision of dot over here? The dots over here is because of this formation of the hydraulic jump. So whatever this profile, this is nothing but S1 profile. And what is this? This is a hydraulic jump. Don't think hydraulic jump is a gradually varied flow. You know the hydraulic jump is a rapidly varied flow. So now, if a pool of water is ended by an obstruction and if the slope is going to be a steep slope, then keep that in your mind. Hydraulic jump is going to be followed by the S1 profile. Hydraulic jump is going to be followed by the S1 profile. I hope you understood. So why I have drawn the hydraulic jump? Because I am at the NDL. I want to reach over here. So I want to rise. But what is the nature of the second profile? Falling. I want to rise. Nature of the second profile is falling. Whenever you are going to be come across second profile, and when you want to rise in the second profile, then second profile will be falling. Rise, falling. It will create hydraulic jump. Or in other words, wherever there is a flow meeting from below serial to above serial, there is a hydraulic jump. So initially I was here below serial and I want here above serial. So below serial supercritical flow, above serial subcritical flow. Whenever the flow meets from super to sub, that is going to be the hydraulic jump. So this is S1 profile. What is the difference between M and S? M means mild, S means steep. M mild slope, S means steep slope means S1. Now come into the S2 profile. So in the case of the S2 profile, where do you see? Flow of water from a reservoir to steep channel. Flow of water from the reservoir to the steep channel. Now let's see that. This is a steep channel where here this is NDL. Here it is going to be serial. Whatever, this is going to be a horizontal bed. So this is a horizontal bed. Okay. This is steep slope and this is a horizontal bed. I am going to discuss about the horizontal later. Okay. Now, this is CDL, and here it is going to be NDL. When I open the full gates, into the steam, you know that the level of water over in the reservoir is going to be this much. Yes or no? So when the level of water is going to be like that, you see everywhere this is CDL. You know that the CDL depth is going to be constant. You know that the CDL depth is going to be constant. Yes or no? Why, sir? CDL depends upon discharge only. CDL does not depend upon the slope. Does the critical depth depends upon the slope? You see here. Does the critical depth depends upon the slope? No. YC is independent on slope. Whether it's a horizontal or mild or steep, I don't care. This is going to be the CDL. Yes. So now I want to meet NDL, my dear. You are here, and I want to meet the NDL. When you want to meet the NDL, you are here and here. So now I want to meet the NDL. When I want to meet the NDL, then the flow must be false or not here. So now how the flow is going to be false is, this is CDL. So here, the water level falls perpendicular to the CDL. And now from here onwards, now I enter into the steep flow, perpendicular to CDL. So now it has to be end with whom? NDL. It has to be end with whom? NDL. And flow is going to be asymptotic to NDL. Flow is going to be asymptotic to NDL. Now, whatever this profile, this is known as S2 profile. Whatever this profile, this is known as S2 profile. And whatever this profile, I will be discussing this profile later. So this profile is going to be the S2 profile. Wherever there is a flow of water meeting from reservoir to the steep channel, then you are going to see the profile as a S2 profile. Okay. Whatever this is nothing but S2 profile, because this is water. And so once the water enters into the steep channel, it has to reach whom? NDL. When it has to reach NDL, it is going to be asymptotic to the NDL. So it's going to be the S2 profile. Similarly, S3 profile. So in the case of the S3 profile means entry of flow through sluice gate. Again, whatever, this is nothing but steep channel. Whatever here, this is going to be the sluice gate. But this time, what is this? This is CDL. And what about here? This is going to be the NDL. Okay. Now, what is the difference between the M3 and S3? Have a look. First of all, when it comes on the downstream side, when it comes, the flow is going to be forms a vena contracta. That you know it very well. So the vena contracta, this is the vena contracta. Okay. Now, on the downstream side, should I have to meet now CDL or NDL? NDL. That's it. See, common point is, if you are discussing about the upstream, always flow starts with NDL. You see, here I am discussing about the upstream of an obstruction. So I am starting with NDL, and here downstream of an downstream NDL. So here also downstream. Keep that in your mind. Always, if you are starting the flow, start with NDL. If you are ending the flow, it should end with NDL. Okay. Now here there is an NDL. Now this is a third profile. Rising or falling? Rising. I want to meet whom? NDL. Yes. Simply I rise. Simply I rise and I'll meet the NDL asymptotical to the NDL. That's it. Okay. whatever this water level, this is known as S3 profile. Is there any hydraulic jump in the case of the steep slope? Is there any hydraulic jump over here? No. Why, sir? Because here CDL is below the NDL, sir. Is there any cross of water level from below CDL to above CDL? No. Hydraulic jump always occur when flow meets from below CDL, means supercritical, to above CDL, means subcritical. Here NDL is below CDL, right? I don't need to cross the CDL. Do I? No. I can just directly touches the NDL. So if you keep the steep slope on the downstream of a sluice, there is no provision of hydraulic jump. But if you provide the means mild slope or lesser slopes on the downstream of sluice, then there is a hydraulic jump. It's all about the type of flow. Because if I send a discharge for some discharge and see this is for some other discharge, this is for some other discharge. I told you clearly earlier, for one flow rate, this slope channel can behave like a mild. For other flow rate, we behaves like a steep. Now, my question for you, does hydraulic jump is going to be helpful for us or not? Yes, it is helpful for us because hydraulic jump will dissipate a lot of energy. Hydraulic jump will dissipate a lot of energy. After this concept, we are going to discuss about that only hydraulic jump. Hydraulic jump will dissipate a lot of energy. When hydraulic jump dissipates lots and lots of energy, it is going to be very helpful for us because it will provide a safety to the downstream side, my dear. It provides safe to the downstream side because when energy is less, then the sides are going to be safe from scouring. So, as a civil engineer, I always prefer less slopes, means mild slopes on the downstream side rather than steep slopes. Because if I provide a mild slopes, then I can have a hydraulic jump. And due to this hydraulic jump, what happens is energy will be dissipated. And moreover, think and say, moreover, on the downstream side, this is going to be subcritical flow or supercritical flow? Subcritical flow. What is meant by subcritical flow? The flow with larger depth and less velocity. So if I can create a hydraulic jump, then on the downstream side, flow moves with a lesser velocity. But if you see the S3, is it a subcritical or supercritical? Supercritical. If you try to allow a flow rate so as to create a steep slope on the downstream side, then the flow is supercritical. What is a supercritical flow with a larger velocity? With this velocity, if it goes to the downstream side, the bed sides are going to be completely eroded. Tell me. So you are a civil engineer. Which one are you going to prefer? When you are lifting the sluice gate, you have to lift the sluice gate by keeping in your mind whatever the flow I am going to send a Q. Whatever the flow I am going to send a Q, that Q should be used for YN and YC and for YN and YC. And I have to make sure that Q should be make sure that YN must be greater than YC. Then only it is going to be a mild slope. I hope you understand these concepts well. It's about the steep slope and mild slope. There are some other slopes also that we'll be seeing after the break. So now it's 8:40. Let's have a breakfast break of 20 minutes. As you are at home only, so the breakfast break 20 minutes, and we'll be start our session again at 9 o'clock. And 9 to 11, I'll take one more session. 11 to 11:15, I'll give a small break. And then from 11:15 to 1 o'clock, we'll go with one session. Because as most of the people are asking 2 breaks. So let's have a break, 8:40, come by 9 o'clock. Okay. Now, next come to the next conditions. See, that's about the mild slope and steep slope. So how the profiles are going to be there and what are the practical applications. And apart from that, we have some other slopes, but we don't use that regularly. Mild slopes and steep slopes are the slopes we used to get regularly. Okay. Here, next, the third one is critical slope. See, when do we say a slope is going to be a critical slope? When do we say a slope is going to be a critical slope? See, mild means yn less than yc, and steep means, sorry, mild means yn greater than yc, and steep means yn less than yc. So now coming to the critical slope, in the case of the critical slope, when yn is equals to yc, we call it as a critical slope. Yn is equals to yc, we call it as a critical slope. So now in the case of critical slope, yn and yc both are same. So yn and yc both are same. That's the reason why I represented both with the blue and red over here. So in the case of the critical slope, yn is equals to yc. When yn and yc both are same, NDL and CDL coincides with each other. NDL and CDL coincides with each other. Yes. So when NDL and CDL both are same, then which profile is missing over here? Can you please tell me? There are three profiles, right? What are those three profiles? Above NDL CDL, between NDL CDL, below NDL CDL. Above NDL CDL, between NDL CDL, below NDL and CDL. So between NDL and CDL, whenever the NDL and CDL both are going to be overlap, then the between space is going to be missed, which means the second profile is missing. So in the case of the critical slope, C2 profile is missing. C2 profile is missing. So when the C2 profile is going to be missing, see, this is a highly unstable slope. The critical slope is going to be it's a very, very highly unstable slope. So we don't create the flow as a critical flow. We don't create the slope as a critical slope because it is a highly critical, highly unstable slope. There is a highly unstable slope. Now, in the case of the critical slope, you see there NDL and CDL both are going to be same. So why I said it's a highly unstable slope is because sometimes we take just above as a CDL, just below as a NDL. Sometimes we take just above as a CDL and just below as an NDL. Because this is a NDL and CDL both are there or not. Now I have to predict the flow behavior. So sometimes just above, it's not beyond line, it's just above, just below. So now whatever the other profiles are going to be C1 and C3, first and third profiles are always rising profiles, right? So just above CDL means, now if I draw, that is going to be asymptotic to, perpendicular to CDL. And now here, asymptotic to NDL. This is a C1 and this is a C3. This is a C1 and this is C3. When you assume just above CDL, just below NDL. Okay. Now, in other times, just above it may be NDL and just below it may be CDL. See, if just above, observe here clearly, let me represent this once again. As CDL and NDL both are going to be coincide, then in order to predict the flow behavior, just above I can take CDL, just below I can take NDL. If I take CDL and NDL, then C1 and C3 are exactly similar to S1 and S3. C1 and C3, you see, this is C1 and this is C3, are exactly similar to S1 and S3. Yes. Now, what if I take just above NDL and just below CDL? If I take just above NDL and just below CDL, then they are going to be behaves like a mild slope. Then they are going to be behaves like a mild slope. So, what I want to say here is, in the case of the critical slope, sometimes just above NDL, sometimes just below NDL. Okay. So here, here, what is going to be happen is due to this instability, we call it as a highly unstable slope. It can be C1, C3 like this, or it can be other ways also. So we generally don't go for the critical slope because it's a highly unstable slope. Okay. Next, fourth one, horizontal. Fourth one, horizontal. Actually, what is the meaning of horizontal? The bed slope is equals to 0. The meaning of horizontal is going to be bed slope is equals to 0. When the bed slope is going to be 0, now just go back here. Please observe, please. You know y is inversely proportional to S naught R naught. Come on, tell me. As yn is inversely proportional to S naught, as yn is inversely proportional to S naught, now yn is inversely proportional to S naught. If S naught is equals to 0, then what is yn? If S naught is equals to 0, then what is yn? Yn is equals to infinity. If S naught is equals to 0, yn is equals to infinity. Okay. And moreover that yc is independent of bed slope. Yc is independent of bed slope. So generally we prefer horizontal for the reservoir purpose, means to store the water, where the yn value means normal depth is going to be infinity. What is the meaning of normal depth infinity? Whatever the depth you allow, that is going to be uniform flow only. Whatever the depth you allow, that is going to be uniform flow only. Okay. So whenever, now you see, what is this line? This line is going to be CDL. What is this line? This line is going to be CDL because the CDL YC does not depend upon S naught, but whereas YN is going to be dependent on the S naught. Okay. Alright, sir. Generally, can I say this horizontal as a mildest version of mild? Can I say horizontal as a mildest version of the mild? See, what is meant by horizontal? What is meant by mild? Very less bed slope. When S naught is less, YN is more. When S naught is less, yn is going to be more. So in the case of the horizontal, this S naught is equals to 0, so yn is going to be infinity. Can I say this horizontal is the mildest version of the mild? What is the mild? Yeah, you see this is a mild, right? You see this is a mild. So if you observe over here, if I make sure very less slope, then yn increases. And you see, in the case of mild, what is the first profile? What is the first profile? Yn to infinity. Yes or no? yn to infinity. The first profile is going to be yn to infinity. Now, if I reduce the slope further and further and further, if I make this mild as a horizontal, if I make this mild as a horizontal, then yn is going to be tends towards infinity. When yn itself is a infinity, then is there any first profile, my dear? Come on, tell me. What is the first profile? Above NDL and CDL. Above NDL and CDL. Above NDL means already yn itself is a infinity. Can you see anything above? Can you see anything above? No. Understood? Can you see anything above? No. So that's the reason why in this case the NDL is infinite. The NDL is infinite. As NDL is infinite, then here H1 profile is missing. The missing profile is going to be H1 because yn is equals to infinity. And from that infinity, whenever the yn is equals to or y is equals to yn is equals to infinity. So in this case, you know that y is equals to yn is equals to infinity. Then what is it? Dy by dx? Dy by dx is nothing but yes, no. Yes or no? So now, how many profiles are there? H1 profile is missing. Then what are the other profiles? The other profiles are going to be the second profile. The second profile is falling or rising? Falling. Falling exactly horizontal. Exactly horizontal. Perpendicular to the CDL. This is H2. And third profile, rising line dot line perpendicular to CDL. This is H3. H2 and H3. H2 and H3. Okay. So I hope you understood what is happening over here. So H1 profile is missing. Why H1 profile is missing? Because yn is infinity. Above infinity, I cannot see the profile. Above NDL, I cannot see the profile. So I am saying that H1 is going to be missing. And from the infinity, whenever infinity, the flow is going to be horizontal or not. So infinity, whatever the depth is there, 10 meters, 20 meters, from there, water level has to fall. So this is going to be the H2. Okay. Now, coming to the last slope. Adverse slope. So what is adverse slope, sir? In the case of the adverse slope means slope is channel bed is rising in the direction of flow. Channel bed is rising in the direction of flow. Okay. So if the channel bed is going to be rising in the direction of flow, then we call it as a adverse slope. Okay. Now what is this? This is known as adverse slope. Where here S naught, see generally the dy by dz by dx is equals to positive S naught, my dear. What is the meaning of positive S naught, sir? Sir, let's go back to the dynamic equation of GVF. Okay. So this is a dynamic equation of GVF, right? Yes. What is the assumption I have made over here? Assume all the falling slopes are negative. Assume all the falling slopes are negative. That is the reason why I take a dz by dx is equals to minus S naught. Yes or no? Why I have taken dz by dx as minus S naught? Because the channel bed is, I am taking the channel bed as a falling. As I took the channel bed as falling, then I got a dz by dx as minus S naught. Now, if I substitute this dz by dx as minus S naught, then dy by dx is equals to S naught minus SF by 1 minus F first. So why I have derived this equation is, in this equation, finally I got this one. when I assumed initially dz by dx as a minus s naught, keep that in your mind. When I assumed this value as minus s naught, then I got this value as a dy by dx is equals to s naught minus sf by 1 minus fr square. S naught minus sf by 1 minus fr square. Okay. So now dz by dx is equals to plus s naught, then dy by dx is equals to minus s naught minus sf by 1 minus fr square. If you have any doubt why I have taken this one, because this is a rising slope, as it is a rising slope, as a yes, as a channel bed is a rising slope, then dz by dx I can take it as positive. If I substitute the dz by dx as positive, if I substitute the dz by dx here, you see, if I substitute this dz by dx as positive, then if it goes to the other side, that is going to be negative minus s naught minus s. So in the case of the adverse slopes, keep that in your mind. In dy by dx equation, it is going to be minus s naught minus sf by 1 minus fr square. So I'll write that as a note point, but as of now. Okay. So adverse slope. Adverse slope means s naught is going to be positive. Remember, S naught less means yn is going to be more and more, yes or no? And S naught is going to be more than the negative value. So then S naught means S naught is going to be positive. If the S naught is going to be increases and increases, so now in this case, see, if the slope is going to be rising, think and say, if the slope is rising, do you think the flow is going to be happen first of all? This is going to be useful in order to store the water. This is going to be useful in order to store the water. So in the case of the adverse slope, what is going to be happen here is yn becomes infinity. Here infinity, here also infinity. Why, sir? Because open channel flow takes place from high datum to low datum or low datum to high datum. Think and say. Open channel flow takes place from low datum to high datum or high datum to low datum. High to low. Here it is no more of flow. It's going to be whatever the water you add, that is going to be stored over there. Whatever the water you add, that is going to be stored over there. But for a given discharge, you can find out the CDL. Again, when yn is going to be missing, A1 adverse, A1 profile is missing. A1 profile is going to be missing. So now A1 profile missing, and here it is going to be like, see why I am taking yn is infinity means if the bed slope is going to be rising in the direction of flow, then the flow will be moves with a very less velocity, and whatever the water you apply, that is going to be stored there itself. See, horizontal and adverse slopes are going to be used to store the water, whereas critical slope is going to be highly unstable in nature. So we don't use for a normal flows, we don't use critical, horizontal and adverse slope for the normal flows. Normal flows we don't use them. So we use them for the storage purpose only. Now the same way how the horizontal looks like, the same way the adverse slope also looks like. Again, horizontal, from horizontal means the water level is going to be horizontal, falls perpendicular to CDL and asymptotic to CDL. Whatever this is, C2, here it is going to be C3, perpendicular to CDL. That's it. So I can write a note point as in adverse slope, okay, dz by dx is plus s naught, then dy by dx is equals to minus s naught minus sf by 1 minus fr square. Minus s naught minus sf by 1 minus fr square. Okay. So this is the equation. In the case of the adverse slope, you have to substitute the s naught as a negative. When you substitute the s naught as a negative, then these things are going to be changes. There was one previous gate question based upon this by giving the slope as an adverse slope. So the only point is you have to take s naught as a, you need to substitute s naught as a negative, means generally dz by dx is positive. So in the entire equation, whatever the dynamic equation I derived, that is for the channel bed falling. But here, this is channel bed rising. So that's the reason why I'm taking a minus over here. Okay. I hope you understood. Yeah. So that's about the different type of slopes. And whatever the dy by dx I am showing you so far, this dy by dx is water surface slope with the channel bottom. Water surface slope with respect to channel bottom. Sir, why you not apply whole bracket minus, sir? What is this, sir? Where are you, sir, my dear sir? I told this, sir, see, yeah, I have a patience, so I can explain you. I'm not changing the total energy line. See, the total energy, if you take minus, total minus, then dH by dx is also going to be plus. What is dH by dx? That is minus SF. Total energy line will not change. Total energy line will be falling only. But only the bed is going to be here dz by dx. Here dz by dx I'm taking minus S naught. There that is going to be plus. So if I write minus as plus, then what is going to be here? This is going to be minus. Okay. This is water surface slope with respect to channel bottom. With respect to channel bottom. Now, what I want is I want water surface slope with respect to horizontal. I want water surface slope with respect to horizontal, which means SW. You know that SW, right? Water surface slope. Or you can also write it as a free water surface slope. Whatever I made so far is with respect to horizontal, my dear. Sorry, whatever I made so far is with respect to channel bottom. If it is with respect to channel bottom. For example, let's take this is a channel bottom. So far and so good. I have taken this one as a x-axis. This is x-axis, right? So far and so good. Whatever the water surface we have been discussed, that is with respect to the horizontal, means with respect to the x-axis. But I want with respect to horizontal. Okay, sorry, this is not C to C3, this is A to A3. Sorry. This is A to A3. Okay. So now, You see, I want with respect to the horizontal now. For that A, if it is a falling profile, how it should be? If it is a falling profile, how it should be? See, so far and so good. I said you earlier itself, dy by dx is not SW. dy by dx is water surface slope with respect to channel bed. Now, if it is a falling profile, this is the water surface. Okay. So that's a falling profile. That's the water surface. Now you see, you observe this is nothing but a falling surface or not? Yes, you know that. And we know that clearly, whatever the horizontal you see, this is horizontal. Let me draw this a dotted line to the back side, and this is channel bed. Whatever the slope of the channel bed with respect to horizontal, this is S naught. And what is meant by dy by dx? Slope of the water surface with respect to channel bed. This is dy by dx. That's dy by dx. What is the dy by dx? Slope of the water surface. Slope of the water surface with respect to channel bed. This is channel bed or water. And what is S naught? Slope of the channel bed with respect to horizontal. Now what I am asking you, slope of water surface with respect to horizontal, which means this is going to be the slope of the water surface with respect to horizontal. So this is a water surface and this is the horizontal. So what is the slope of water surface with respect to horizontal? Now that is SW. In the case of the falling profile, what is SW? Come on, tell me please. In the case of the falling profile, SW is nothing but S naught plus dy by dx. Can I write like this? S naught plus dy by dx. So whenever it is going to be a falling profile, see, first of all, you need to find out the dy by dx. In examination, sometimes they ask about the what is the free water surface slope or water surface slope with respect to horizontal, they'll ask. Instead of channel bottom, they'll ask about the water surface slope with respect to horizontal. So if they ask with respect to horizontal, you need to find out the SW. So if it is a falling profile like this, then I'm going to find out the SW as dy by dx plus S. So I don't think why some of the people, while I am discussing something, you please observe this, my dear. Yeah, I hope some of the people get doubts. I don't have any problem with that. But some of the people are just, I'm thinking, maybe I am wrong also. Some of the people are trying to give, means they are thinking like what the reply I have to give for what the sir is saying. Instead of listening what I am saying over here, you are trying to give reply for what you are understanding. That's it. And while you're doing so, you're missing some more important points, my dear. While the concept is going on, you please focus on the concept. If you don't focus on the present concept and if you stick on the past concept, then if I go for the next concept, then you're asking the concept for the previous one. I told you many number of times. Yes. Once the concept is completed, then you can ask me. And meanwhile, you're asking, sir, why it's going to be SW, why it's going to be S now. Think, Baba, think. Okay. So now this is going to be falling profile. Now, coming to the B, what if it is a rising profile? What if it is a rising profile? So if it is a rising profile, what is meant by rising profile? Rising profile means the depth is going to be increasing in the direction of flow y1 and y2. The depth is increasing in the direction of flow. Yes or no? So now in the case of the rising profile, now you see, let me draw the points once again. This is a channel bed, and here water surface is going to be rising. Water surface is going to be, don't think this is falling, my dear. There is a rising. Whatever this is horizontal. You see now what is a SW? What is SW and what is dy by dx? What is meant by dy by dx? Slope of water surface with respect to the channel bed. This is dy by dx. Okay. What about S naught? Slope of channel bed with respect to horizontal. This is going to be S naught. And now what about the slope of water surface with respect to horizontal? This is horizontal and this is bed, channel bed. So whatever, this is nothing but SW. So now whatever the slope of this water surface with respect to horizontal is SW. So now in this case, can I write the SW is equals to S naught minus dy by dx. So S naught minus dy by dx. You just simply, you know the meanings, right? You know what is meant by dy by dx. This is a water surface. From the water surface to channel bed, dy by dx. From the channel bed to horizontal, S naught. From the water surface to horizontal, SW. From the water surface to horizontal, SW. From the water surface to channel bed, dy by dx. From the channel bed to horizontal, S naught. So in falling profile, you are going to take SW as a S naught plus dy by dx. And in rising profile, you are going to take the SW as S naught minus dy by dx. So the conclusions that I have made so far here is, the conclusions are, always first and the third profiles are rising, but second profile is falling profile. Always first and third profiles are rising, but second profile is a falling profile. Okay. Next, point number 2. Always GVF meets asymptotical to NDL and perpendicular to CDL. Always GVF meets asymptotical to NDL and perpendicular to CDL. Okay. Always GVF surface starts with NDL and ends with NDL. Starts with NDL and ends with the NDL. So these are the points that we need to know. And how to determine whether the slope or not beta. See, how come you say whether it's a mild or steep? How come you say whether it's a mild or steep? When based upon the yn and yc, if I can find yn and yc, then based upon that I can say. So now let's solve some practice questions based upon this, and then we'll go for. That's not the end of the GVF. Still some things are there. I have given you one slope at a time, steep and mild, and I'm going to discuss in the next means after the practice questions. I'm going to discuss about what if I club all those channel sections, means what if I provide different slopes. So that we will be seeing later, but as of now. Why sir here S0 is not negative in falling profile? I'm not discussing about the magnitudes over here. I'm discussing about the directions. So forget about this. Everything is going to be negative then. dy by dx is negative, S0 is negative, and SW is also going to be negative. You substitute all the negatives, everything is going to be gets cancelled. This is not falling. You see, observe, this is a depth y1 and this is a depth y2. Is it rising profile or falling profile? You please tell me. Y2 is more than y1 or not? Okay. So now let's solve some questions regarding to that. Yeah. So now I hope you can see this question. Yes. Water flows in a triangular channel of a side slope, one horizontal to one vertical. One horizontal to one vertical. And a longitudinal slope S0 is equals to 0.001. Longitudinal slope S0 is equals to 0.001. Discharge of 0.2 meter cube per second flows through it. Discharge of 0.2 meter cube per second flows through it. Assume Manning's as 0.015. And whatever the given flow depth is 0.5 meters, what is the profile? First of all, my dear, see, this is the flow depth, right? This is the flow depth. Okay. Now, you see the options, there are M, S2, M1, EC1. See, first of all, if you want to say whether it is M1, M2, M3 or S1, S2, S3, you need to find out Yn and Yc. Already I have given Y value, right? Already I have given Y value. If I know Yn and Yc, keep that in your mind, then by using Yn and Yc, I can say the type of slope, whether it's a mild or steep or critical. And once I know Yn, Yc, then I can compare, means I can compare with Y value, whether the Y is more than Yn, Yc, in between or less than, so that I can say the profile. So first of all, we need to determine that Yn and Yc. So determination of Yn. So how you are going to find out the Y answer? I told you by means of the Manning's equation. 1 by n into r to the power of 2/3 into s to the power of 1 by 3. So 1 horizontal to 1 vertical means m is equals to 1, which is nothing but, what is the meaning of m is equals to 1, my dear? What is the meaning of m is equals to 1? Come on, tell me. When m is equals to 1, it is nothing but a hydraulically efficient triangular section or symmetrical triangle with apex angle 90 degrees. So by m is equals to 1, I can directly say If m is equals to 1, area is equals to y square and r is equals to y by 2 root 2, because m is equals to 1 means symmetrical triangle with apex angle 90 degrees. Symmetrical triangle with apex angle 90 degrees. Okay. So now I need to find out the normal depth. I need to find out the normal depth. So in order to find out the normal depth, just substitute q is equals to y square into 1 by n into y by 2 root 2 whole to the power of 2/3 s to the power of 1 by 2. Now I want yn. Whenever I write y as yn, then s becomes s naught. You know that in the case of the uniform flow, see I am representing later. In the case of the uniform flow, then S becomes S naught. And in the case of the GVF, S is equals to SF. So now Y becomes Yn. Now I want Yn, right? So Q is equals to Yn into, means Yn, 2 plus 2 by 3, Yn whole to the power of 8 by 3 by 2 root 2 whole to the power 2/3 S naught whole to the power of 1 by 2. Now you please substitute these values. What is the Q value given? 0.2 is equals to 1 by n, 0.015 into yn whole to the power of 8 to the 2 root 2 whole to the power of 2/3 s naught 0.001 whole to the power of 1 by 2. What is yn value? What is yn value? So come on, find it out. I hope you got the yn value as 0.536 meters. Yes. So it is going to be 0.536 meters. See how I have find out the yn. I write down the Manning's equation and I'm substituting if y as yn, then s is equals to s naught. Then I can find out the yn value. And once I know the yn value, then I can find out the yc. So you know that for the triangle yc is equals to 2q square by gm square whole to the power of 1 by 5. That's for the triangle. Okay. So 2 into, what is the q value given? 0.2 square by 9.81 into 1 square whole to the power of 1 by 5. Please find out this yc value. So if we solve, it's going to be 0.38 meters yc value. So now I got yn and I got yc. As yn is going to be greater than yc, then what is the type of slope this one? This is a mild slope. And given flow depth, y is equals to 0.5 meters, which is less than yn and more than yc. So y is going to be less than yn and more than yc. As it is in between, my dear, as it is in between, so flow depth lies between NDL and CDL. What is the type of profile here? The answer is going to be M2 profile. So whatever the answer, that is going to be the M2 profile. So this answer is going to be the M2 profile. So just this is how in a given channel, if it is a GVF, whether it is a rising or falling, we can say by finding the yn and yc, and we can state the type of slope. And based upon the type of slope, I can say the type of profile also. Okay. So have a look about this. How I have find out. I hope your doubts have been clarified with this, how to determine the yn and how to determine the yc. See, this is a triangle. If I would have given rectangle, then what is yc? Q square by g whole to the power of 1 by 3. Okay. Now let's see the next question. I hope you understood this question. Yeah, this is a gate question. In the case of gate question, calculations would be there, right? Calculations would be tedious. You must have to go through. If I say in ESC, in ESC they don't give these type of questions. In ESC, the pattern would be a little bit different. That will be solved. We'll solve. Now, come to the next question, question number 19. You see here a rectangular stream of width. So again, given is a rectangle of width. What is the width? 15 meters. And depth is going to be 3 meters. The slope of the stream bed is 1 in 5,000. Total discharge 29 meter cube per second. And see what is meant by C? Chezy's coefficient. What is meant by C? Chezy's coefficient. So this time they mentioned as Chezy's coefficient. C value 65. If the depth is increasing in the direction of flow, if the depth is increasing in the direction of flow, what is the meaning of depth is increasing in the direction of flow? Rising profile. If the depth is increasing in the direction of flow, then the slope of the free water surface, which means they're asking SW. What is the slope of the free water surface? The water surface slope with respect to horizontal. So now for the rising profile, just now I mentioned for the rising profile, SW is equals to S0 minus dy by dx. That's it. So I want the slope of the free water surface profile, right? So I want the slope of free water surface. Okay. Now I need to find out this SW. SW is equals to S0 minus dy by dx. Okay. I have S0 with me. Now what is the dy by dx? What is dy by dx? S0 minus Sf by 1 minus Fr square. S0 minus Sf by 1 minus Fr square. Okay, first let's find out the Froude number. Let's find out the Froude number. So given is rectangle, right? So what is our Froude number? Fr square is equals to V square by Gy for rectangle. Because in the case of the rectangle, D is equals to Y, right? So now I need to find out the velocity. First I find out the velocity because you know Y, what is the Y value? 3 meters. So first you find out the velocity. Velocity means discharge by area. Velocity means discharge by area. So what is discharge? 29 by area, 15 into 3. So 29 by 15 into 3, which is going to be 0.64. Now you substitute this 0.644 square by 9.81 into what is the Y value? 0.644 square by 9.81 into Y value is going to be 3. So which is going to be 0.014. 0.014. So you keep the FR square aside. You keep the FR square aside. So now my dear, I want SW. In that I know S0. I need dy by dx. For the dy by dx, I have the denominator. I have the denominator. Now you see, I know the denominator. I know S0. Now the question is going to be S. So just similar to the previous question, here when I keep y as yn, S becomes S0. So now you know that for GBF, y should be y only and S should be S. Now again from Manning's and Chegis equation. From Manning's and Chegis, see, in this question they have clearly mentioned that is Chegis. So when I mention that it's going to be Chegis, then you see, what is a Q? Q is nothing but A into C root RS. Okay, now you know that what is the R value? Once you know this, now area, what is area? Area means 15 3 is a 45, or I can directly write what is R value over here. R value means A by P, B by Y, B by plus B plus 2Y. 15 3 is 45 by 15 plus 2 into 3. 2.143. 2.143. So now 2.143. So R value is equal to 2.143. Now you can substitute over here, because now if I am going to write S as SF, now I need whom SF, right? I need whom SF. Then I am going to give Y as Y only. So what is the discharge given? 29 is equals to area. What is area? 15 3 is 45 into C value 65 into root of R. What is R? 2.143 into SF. So now let's find out the SF value. What is SF value? So now SF value is going to be 4.587 into 10 to the power of minus 2. So if you find out the SF value, that's going to be 4.587 into 10 to the power of minus 2. So now I have everything with me. I have S naught, I have SF, I have FR square. So now you please substitute in the dy by dx. Now dy by dx is equals to, what is S naught? 1 in 5,000 minus 4.587 into 10 to the power of minus 5 by 1 minus, what is FR square? 0.014. Now 1 in 5,000 answer by 1 minus 0.01. So this value is going to be 1.56 into 10 to the power of minus 4. Whatever this value is going to be, 1.563 into 10 to the power of minus 4. Okay. So that's dy by dx. But I want whom? SW. So what is SW? S naught minus dy by dx. S naught 1 in 5,000 minus 1.563 into 10 to the power of minus 4. So the answer is going to be 4.368, and in 2 decimals 4.37 into 10 to the power of minus 1. This is the answer, 4.37 into 10 to the power of minus 5. Finally, have a look about that. Sir, why you use the Chegis equation? Sir, you see, sir, here, what is the C value they have mentioned? They have mentioned C value as 65. So as they mentioned the Chegis, then I can find out the Chegis equation only. Okay. I have mentioned the Chegis, so that's why I use Chegis equation. Okay, I hope you understood this. So I hope you know how to classify a slope, whether it is a mild or steep, and how to find out that yn and yc. And I hope you understood how to determine the SF also now. If I keep y as y, then s becomes sf. Okay. So that's about these two questions. Next. Okay. So now you see this question, please. Okay, one of my dear student is asking, sir, they asked the slope of water surface, but they did not mention, sir, with respect to what? My dear, I was clearly mentioned that there is a slope of whom? Free water surface. And I mentioned, if you go back, what is this? Tell me, what is the heading I have mentioned? Free water surface slope. Water surface with respect to horizontal or free water surface slope? Okay. So now you see this question. Now we see this question. See here I am giving you the type of curves M1, H3, H2, A2. I have mentioned you those things earlier itself. Now, so I'm asking you the list to flow condition. What is M1? Where do you see the M1? We do observe the M1 on the back of an obstruction. Yes or no? So the M1 is nothing but you know the M1 is occurs is nothing but rising, right? Rising profile, and this rising profile is going to be backwater curve. Backwater curve. Now you can ask me, Aresa, this is H3, na? H3 is also going to be hydraulic, sorry, H3 horizontal, third profile is also going to be rising profile. Yes or no? You see, there are two options. M1 is there and H3 is there. M1 is rising and H3 is also rising. So we call M1 and H3 both are going to be backwater profiles. But now, which one I have to choose is for M1 only. Why, sir? Now you see, when do you say the H3? When do you say the H3? Look, if I provide a horizontal slope over here, if I provide a horizontal slope, this is horizontal medium. If I provide a horizontal slope, okay, and this is going to be the sluice gate. This is going to be the sluice gate. And whatever here, this is going to be the CDL. And NDL is going to be literally infinity. NDL is going to be literally infinity. Then how does the flow is going to be happen? In this case, the flow is going to be created. This is going to be H3. And there is a hydraulic jump rises up to the maximum. Up to the maximum. Okay. So whatever this profile is going to be the H3 profile. Whatever this profile is going to be the H3 profile. So I can say for M1 it is going to be rising curve. So that's I can write for M1 it is going to be 2. But for H3 you can say the hydraulic jump is going to be occur. See, for lesser slopes like mild slopes and horizontal slopes, for their third profiles M3 and H3 are going to be followed by hydraulic jump. So now for H3 it is going to be followed by hydraulic jump. Once H3 occurs, there is a hydraulic jump. Once H3 occurs, there is a hydraulic jump. So for M1 it is going to be 2. For H3 it is going to be 3. Now you see the options 2 and 3. So the options are going to be option D. Else I go for the next things. You know the meaning of H2. What is the meaning of H2? S2 means a fall, right? S2. Have you remember the S2? S2 means fall. And now you just go back. Yeah, I hope you see this. See, this is above CDL. This is going to be subcritical. And here it is going to be supercritical. Okay. Whenever the flow meets from super to sub, I said you that's a hydraulic jump. That's hydraulic jump. And whenever the flow meets from subcritical to supercritical, this is S2, right? What is S2? Flow is meeting from subcritical to supercritical. And whenever the flow meets from subcritical to supercritical, did I mention as a hydraulic drop? Hydraulic drop, yes or no? So you please observe in the starting itself, I mentioned those. Yeah. So this is a C. Whatever this is nothing but hydraulic jump, and here is nothing but the hydraulic drop. Wherever there is a flow meets from a sub to super, that's going to be hydraulic drop. Jump means super to sub. Drop means sub to super. Okay, now you see. So for S2, S2 is falling. Means we can call it as a hydraulic drop. And what about A2, sir? What is A? A means adverse, right? What is mean by adverse? Slope upward in the direction of flow. What is A2? A2 is nothing but A2 is also falling, but from the given options, see A2 is also falling. But from the given options, A means adverse. Adverse means slope upward in the direction of flow. This is nothing but adverse slope. Okay. So in this, the examiner has given you to make sure to get deviate from the options. Both M1 and H3 are first and third profiles, both are rising. Rising means backwater, but there's only one backwater profile. So out of these two, which one is going to be clear? That M1 I can say it is backwater, and for H3 there is a formation of hydraulic jump. So for M1 I gave 2, and for H3 I gave hydraulic jump. Now S2 and A2 both are falling. S2 second profile, both are falling. Falling means a drop. But which one I have to check? S2 has hydraulic drop. Why? What is mean by A? A means adverse. What is mean by adverse? Slope is rising or increasing in the direction of flow. In the direction of the flow. So I hope you understood this. Now that's about question number 21. Let's see this question. Okay. Does my voice is clear to you people? Does my voice is clear to the people? Clear to you? Lagging now. Why it is lagging? Now is it clear or not? I hope it's clear. Mr. Maruti Sawant, you please try to check your internet because most of the students does not have any problem as like lagging or sound not audible. So you please try to check your internet connection once again. Okay, fine. Now let's come to this question. A wide rectangular channel has a longitudinal bed slope of 0.0004. A wide rectangle, see given is a wide rectangle. Mind it, they mention clearly the given is going to be a wide rectangle. Wide rectangle, and what is the bed slope mentioned? 0.0004. If the channel is a several kilometers long, so the channel is a several kilometers long, the flow depth near the downstream end for a flow of 2 meter cube per second per meter. So what is the discharge per unit width they given? 2 meter cube per second per meter. Under free fall condition, what is the meaning of free fall condition, sir? See, the channel is very long. Under free fall condition means there is a fall, there is a drop, there is a drop. So this is a drop. Okay, assume Manning's n is equals to 0.012. Now we need to know what is the flow depth near the downstream end. Means when the flow is going to be fall, what is the downstream depth? What is the downstream depth? Means at this point, what is the downstream depth? That's what I'm asking you. So what is the flow depth near the downstream end of for a flow of Q 2 meter cube per second per minute? Question number 1. Do we know what type of slope it is? Do we know what type of slope it is? We don't know. So we need to find out the type of slope, right? Now, for a wide rectangle channel, already I have given. For wide rectangle channel, I have already given yn whole to the power of 10 by 3 is equals to q square n square by s naught. Q square n square by s naught. Have you remembered this formula? So now you please go back. Yes. You can see this formula for the wide rectangle channel. How to determine yn, please? In the case of the wide rectangle channel, yn whole to the power of 10 by 3 is equals to q square n square by s naught. Q square n square by s naught. Yes or no? And you know yc. Yc is nothing but q square by g whole to the power of 1 by 3. Now, you see, now you find out there is a q, there is a n, and there is a s naught. Q 2 square into 0.012 square by s naught. 0.0004 whole to the power of 3 by 10. That's yn. So find out yn, please. 4 into 0.012 square by 0.0004 whole to the power of 3 by 10. So the value is going to be 1.11 meters. Yes. Similarly, you find out the yc. Q square by g whole to the power of 1 by 3. So now q square 2 square by g 9.81 whole to the power of 1 by 3. What is this value? What is this value? So 4 by 9.81 whole to the power of 1 by 3. The value is going to be 0.74, my dear. This is 0.74 meters. So now yn is greater than yc. From these values, yn is greater than yc. Then what is the type of slope this is? That's a mild slope. I can write this one as a mild slope. And if I know this as a mild slope, my dear, now you know that whatever this is CDL and whatever here, this one is going to be the NDL. And under the free fall condition, so free fall condition means water level will fall like this. Yes or no? Under the free fall condition. See, if it is going to be a free fall condition, they mentioned that under the free fall means the water level is going to be falling. And on the downstream side, what is this depth, my dear, please? This depth is nothing but, you see, this is nothing but yc, right? This depth is yc. The depth is going to be yc. So I can write simply here, this is 1.11 meter. So under free fall condition, under free fall, the flow depth on downstream is equals to yc. And what is that yc value? 0.74 meters. So the answer is going to be y is equals to yc is equals to 0.74 meters. I hope you understood. Let me repeat this question again. See, I have provided you some slope for a wide rectangle. So, and I'm asking you, this channel is several kilometers long. There's a flow depth near the downstream end. Near the downstream end under free fall condition. See, under free fall condition, near the downstream end, Free fall means that is a drawdown. That's a drawdown. But we don't know whether it's a mild or steep. We don't know whether it's a mild or steep. So I have find out yn, I have find out yc, and I check this is mild. So if I say mild, then the water level will fall on the downstream side like this. Yes or no? Then what is the downstream depth over here? What is the depth of the flow on the downstream of the canal? YC. And that answer is going to be 0.74 meters. This one is going to be 0.74 meters. Now I hope you understood this. So how to find out whether it is a yn and yc right now. So these are regarding the hydraulic jump, so that we'll discuss later. Now you see, so some of the previous ESC questions, I told you most of the questions appeared in ESC is from this topic only, GVF. This GVF is very, very important, especially in the case of the ESC. So match list 1 and list 2. They have given the normal depth, critical depth. See, I told you yn or y0. I told you in the starting terms related to the uniform flow, yn or y0. Y0 is also given in some textbooks. So y is a depth of gradually varied flow. Now, they have given flow regimes for gradually varied flow. So they gave y0, they gave yc, and they gave y. Whatever the flow regimes for the gradually varied flow, they have given some options of A, B, C, D. And for those, first let's see for the A, yc is greater than y0, or see, I'll take this as a for our convenience. I'll take, you know, this y0 is nothing but yn. Y0 is nothing but yn because normal depth, right? Yc is greater than, yn is greater than y. See, whenever yc is greater than yn, just now we discussed, right? So when yc is going to be greater than yn or yn less than yc, this is a steep slope. Steep slope, and moreover, yc is more than yn is more than y, which means the flow depth is going to be lying very well below. Okay, so if this is a slope, if yc is greater than yn is greater than y is very, very less. Y is very less means third profile or not. So flow depth below NDL and CDL. Then the answer is going to be steep slope and it is going to be S3 profile. So for A, it is going to be S3. S3 means for A, it is going to be 3. Now go to the options. For A, it should be 3. Eliminate option A, eliminate option D. Now the answers is going to be either C or B. Okay. Now coming to the capital B. What is capital B? Now this time YC is less than YN is less than Y. So from this I can write YN is more than YC. YC is less than YN means YN is more than YC, mild slope. YN is going to be more than YC, mild slope. And you see YC less than YN less than Y, which means all the NDL and CDL is less than Y, which means flow depth lies above NDL and CDL, which means M1 profile. The profile is going to be M1. So for B it is going to be M1. Where is M1? 2. So now what should the correct answer? The correct answer is going to be C. You can eliminate B. I hope you understood. We know that when to say whether it's going to first profile or second profile or third profile, when to say whether it's a mild or steep. Okay. Similarly now, what about the C value? You can say directly the C. Yn is greater than Y, mild slope. Yn is greater than Y, greater than Yc. So this is a mild slope. Yn greater than Yc, mild slope, and Y is in between. Then it is going to be M2 profile. is going to be M2 profile, so it should be 4. Now D, Y greater than YC greater than Y naught. Y greater than YC greater than YN. YC is more than YN, steep slope. Y is more all of those, then it is going to be S1 profile. So S1 means 5. So the correct answers are going to be 3, 2, 4, 5. I told you that's the reason why. So these profiles are very, very important. So how does the topic of open channel flow give a poll? Why it is asking signing for me? Okay, I don't know the signing. Forget about the signing. We don't require any signing. Okay, fine. What if it's got 7? Yeah, suddenly connection lost. So back now. Yeah. So this was a question that we have been discussed earlier, and now coming to the ESE. Yes. So ESE, this question we discussed now. Let's see. Uh, yes, we will see this question later. So for this one, you just go through this that I'll be discussing now. Just go through this. I'll be discussing now because I'm going to discuss this question now. Okay, wait for that moment. Okay, you see this question, please. Consider the following statements are related to a water surface profile in gradually varied flow in open channel. M1 and S1 curves approach Y0. Y0 means Yn only. Y0 or Yn both are same. So normal depth. M1 and S1 curves approach Y0 line asymptotically, means normal depth asymptotically, and tends to be horizontal as Y tends to infinity. See, M1 is going to be touches to the M1. What is M1? M1 means this is NDL and this is M1. Yes or no? So M1 is like this. But in the case of the S1, this is going to be CDL and it is going to be perpendicular to the CDL and asymptotic to horizontal. Yes. So this is S1 and this is M1. M1 and S1 curves approach Y0 line asymptotically. S1 does not touch the NDL and S1 is asymptotical to perpendicular to CDL. So this statement is not going to be correct. M1 is correct, but S1 is not going to be correct. Okay. Now M2 and S2 curves meet Y0, means YN line NDL horizontally and Y0 line asymptotically. It's not Y0, my dear. It's this is YC. This is YC. M2 and S2 curves meet YC line horizontally and Y0 line asymptotically. No way. See, M2 and S2 means they are in between NDL and CDL. They are in between NDL and CDL. So for YC means CDL. YC line means CDL, critical depth line. Always the flow is going to be perpendicular, but they are saying horizontal. So this is also not going to be correct. First one is false and second one is also going to be false. Now you see M3 and S3 curves meet a Y0 line normally, Y0 line normally, and also meet the channel bed normally. No, actually M1 and S1 curves approach and tend to be horizontal as Y tends to infinity. Yes. Okay, there is some problem with this question framing itself. I'll see this and I'll let you know, because in this framing of the question there is some slight problem. There might be some mistake in this question. I'll see this question and I'll let you know later. So as of now, I don't want to make you to confuse much more better, but let me see this and I'll let you know later. Okay. Now coming to the gauge. In the case of the gauge, okay, now you see this question. There is a previous gauge question. A long prismatic channel ends in an abrupt drop. Long prismatic channel abrupt drop. This is a abrupt drop. Choose one of the following statements that adequately explains the water surface profile on the upstream of a drop. On the upstream of a drop. So for an initially subcritical flow, you know that initially subcritical flow. See, obviously this channel is going to be like a mild channel only. You don't need to say all these things because it is going to be a fall, right? This is going to be a fall. So obviously this flow is going to be located between NDL and CDL. So whenever there is a abruptly drop, then the flow is going to be drawdown curve. So now the water surface lies between critical and normal depth lines. Yes. Water surface profile starts from critical depth line and joins the normal depth line. No, because this is NDL and here it is going to be CDL. Whenever there is an abrupt drop will be like this, which means flow is asymptotic to NDL, perpendicular to CDL. Water surface lies wholly above normal depth line. No. Water surface lies wholly above normal depth line. No. Wholly below normal depth, critical depth line. No. So the water surface is lying between NDL and CDL. Just now we have seen all these things, right? So the correct answer is going to be option A. Now, let's see the next question. Yes. The water surface profile resulting from the underneath of the gate in figure. So this is a one more question. What is the water surface profile? What is the water surface profile? See, this is the water surface profile and it is rising or not? Yes. And as it is going to be rising, is it going to be first profile or third profile? This is going to be the third profile, my dear. This is the third profile, okay? So it's not going to be S2. And moreover, the given is horizontal. So H1, H2, the answer is going to be H3. This is a H3 profile. That's a H3 profile. Up to that point, that's going to be the H3 profile. Because the given slope is horizontal, so eliminate yes. And as it is rising, third profile. And now, these questions, I have seen the questions. These are regarding the hydraulic jump. Now, a channel with a mild slope is followed by a horizontal channel and then by a steep channel that we'll be discussing now. That's nothing but a combination of the slopes. And after this, yeah, now you see, this is gate 2007. The flow rate in a wide rectangular channel, again, the flow rate in a wide rectangle channel is a Q 2 meter cube per second per meter. The channel bed slope S0 is equals to 0.002. The channel bed slope S0 is equals to 0.002. The Manning's roughness coefficient 0.012. So they're asking the slope of the channel is classified as. See, one of the classroom practice questions, I have solved this one. Yes. Whenever I give you the wide rectangle, then what is the Yn formula? Yn whole to the power of 10 by 3 is equals to Q square N square by S0. So what is Q square? 2 square N square 0.002 square by S0. 0.012 square by 0.002 whole to the power of 3 by 10. That's a Yn value. So find out the Yn value, please. The Yn value is nothing but 4 into 0.012 square by 0.002 whole to the power of 3 by 10. So the answer is going to be Yn as 0.68 meters. Okay. So now, similarly, find out the Yc value. See, whenever you want to find out the what type of slope, that's it. You just find out Yn and Yc. What is Yc? Q square by G whole to the power of 1 by 3. 2 square by 9.81 whole to the power of 1 by 3. If you solve, this is going to be 0.74. If you solve, this is going to be 0.74. So now here this Yn is less than Yc. When Yn is less than Yc, what's the type of a slope? Steep slope. When Yn is less than Yc, what's the type of a slope? Steep slope. That's it. Okay. So what is the answer over here? D. So you can find out the yn value and you can find out the yc value and you can say what is the type of a slope as a steep slope. So please go from the basic Manning formula. See, I have derived this equation. You please go back and you have a look how I have got this equation. Because see, for first time you can go with the Mannings and all those things, but every time in the examination you don't get that much time, right? So how I got this one, you please refer. Dynamic equation of GVF. There I have given this equation. Now let's see the next question. So we have see this one. Okay, now you see this question, please. A short reach of a 2-meter wide rectangle. See, this is not a wide rectangle. This is 2 meter wide, which means given is rectangle. What is the width? 2 meters. Open channel, and its bed level is rising in the direction of flow. Bed level is rising. Bed level rising in direction of flow. That is nothing but adverse slope. You know the bed level rising in the direction of flow, that's nothing but the adverse slope. Okay, and what is the slope value? You know that S naught is given as a 1 in 10,000. 1 in 10,000. That adverse slope rising is going to be 1 in 10,000. Very less. 1 in 10,000 means for every 10 meters, you are going to see a rise of 1 mm. For every 10 meters, you are going to see a rise of 1 mm. It carries a discharge of, what is the discharge, please? Q, 4 meter cube per second, and Manning's roughness coefficient is 0.01. The flow in this reach is gradually varying. So the flow in the reach is gradually varying. At certain depth in the section, the depth of flow Y is given as a 0.5 meters. Now, the rate of change of water depth with the distance, which means they are simply asking a dy by dx only. They are not asking about the SW, my dear. They are asking about the simply dy by dx. So now, I need to find out for dy by dx. I told you clearly for adverse slope. For adverse slope, you know that dz by dx is a plus S naught, and you have to write down the dy by dx equation as minus S naught minus SF by 1 minus FR square. 1 minus FR square. Okay. So now I have S naught with me. I have S naught with me. And now I need to find out the SF. You know how to find out the SF and you know how to find out the FR square. Let's find out those. See, I told you how to determine the SF. You know that for GVF, if I write Y as Yn, so Y, then S becomes SF. And now in this question, did they mention Mannings or Chegis? Mannings. In one of the classroom practice question, I have given you the Chegis. Their free water surface slope, right? I hope you remember that. Just have 20 or 25 minutes back. So we have been discussed about that free water surface slope. But this time I'm asking you directly the dy by dx only. I'm not asking you SW. I'm asking you dy by dx. So now from the Mannings, Q is equals to A into 1 by N into R to the power of 2/3 into S to the power of 1 by 2. So I want to find out SF. So what is area? B into Y. What is area B into Y? B 2 meters, Y 0.5 meters. 2 into 0.5, which is going to be 1. And what is R? A by P. So by B plus 2Y, which means area as 1 by B 2 plus 2 into 0.5. So which is nothing but 2 into 0.5 is going to be 1. 1 by 3, 1 by 3, you keep like that. So now you please substitute the values over here. So what is the Q value I mentioned? 4. And what is the N value? 0.01. 4 is equals to area 1 into 1 by 0.01 into R value 1 by 3 whole to the power of 2 third into SF whole to the power of 1 by 2. Can you please tell me the what is SF value? Is going to be 6.92 into 10 to the power of minus 3. That's SF. This is SF, right? Now we need to find out the dy by dx. So what is dy by dx? The dy by dx is equals to minus S naught minus 1 by 10,000 minus SF. 6.92 into 10 to the power of minus 3 by so you can write 1 minus FR square. We did not find out the FR square, right? So find out the FR square. What is FR square? V square by GY, because we are discussing about the rectangle. So what is V value? And you know that that V is nothing but Q by A. So where Q 4 by A 2 into 0.5, which is nothing but 4 meter per second only. 4 square by 9.81 into Y given as 0.5. So can you please tell me the first square? So 4 square by 9.81 into 0.5. So that's going to be 3.26. So now 1 minus 3.26 square. 1 minus 3.26 square. So I hope you got this. Then what about the Froude number? So what is the dy by dx now? Tell me please. One in 10,000 minus 6.92 into 10 power of minus 3. Minus 6.92 into 10 power of minus 3 divided by 1 minus 3.26 square. So what is this value, please? Yes, sir. The G value is given as a 10, right? Sorry. The G value, it should be here as a 10. 10 into 0.5, which means 5. So 16 by 5, it is going to be 3.2. Now it is going to be 1 minus the first square means 3 point, that's it. 3.2 only. That's not square also. So minus 1 10,000 minus 6.92 into 10 to the power of minus 3 divided by 1 minus 3.2. So if you solve this, then you're going to get the answer as what is this divided by dx? 3.19 into 10 to the power of minus 3. I hope you got the same answer. The answer is going to be 3.19 into 10 to the power of minus 3. Yes. 3.19 into 10 to the power of minus 3. So I did not give you the options over here. I did not give you the options. So what is the answer? 3.19 into 10 to the power of minus 3 or You can write this one as 0.0019. Can you write like this? Yes. 0.0019. So 0.00319. Okay. So this is how we need to find out the dy by dx. So since it is a wide rectangle, remember it's not a wide rectangle, it's a 2 meter wide rectangle. It's a 2 meter wide means the width of the rectangle is 2 meters. So the answer is going to be 0.00319. That's it regarding to this question. I hope you solved. Means this is a second model we have been solved, but there I discussed about the free water surface. So this is the normal water surface divided by dx. And then we have seen conditions. So still some topics are left over. So we'll see the remaining things now. So there are no other questions left over. So some topics are left over in the GWF itself. And once we solve those topics, then we can come back to the conditions. Now let's see. So far and so good. These are the discussion I made. How to determine the type of a slope and how to predict the type of profile and how to predict whether it is rising or falling and what are the field or practical examples. Now I will introduce, see, so far and so good. I have given you only one channel item, which means, for example, if I take a steep, I'll give you only steep or I'll give you only mild. Now, what if I combine those slopes? The combination of the slopes. The combination of the slopes. Okay, have a break, small break, and a lot of people are asking. Have a small break. It's already 10:55. Have a small break of 10 minutes, 15 minutes. We'll start our session with a new topic and we'll complete that after the break. So have a small break. Okay, let's get back. And now let's see the combination of slopes. So the combination of the slopes. See, we have been discussed about an individual slopes separately, and now we'll see what is the combination of these slopes. Okay. Now, in the case of the combination of the slopes, we take two or more slopes and we are going to do it. And I told you earlier that transitions means not only the shapes but also the change or break in slopes. Okay. So now in that, yeah. Let me take one example first. If a mild slope followed by steep slope. Mild slope followed by steep, which means so mild means lesser slope followed by steep means first would be lesser slope and then it is going to be the steep slope. So we take that. Initially it is a mild slope. And then it is a steep slope. So first mild slope and then followed by a steep slope. So now when do you say mild slope? When do you say mild slope? When yn is going to be greater than yc, we said as a mild slope. Yes or no? So now, there, whatever this junction where the channel is going to be break, let me take it as a dotted line. First, you represent the slope NDL and CDL. So in the case of the mild slope, you know NDL is going to be more than the CDL. Yes or no? This is NDL, and somewhere over here this is going to be CDL. So NDL and this is going to be CDL in the case of the mild slope, and then there is a steep slope. So see, whatever the slope it may be, for a given flow rate, the critical depth is going to be constant and it is independent on the side slope. Sorry, independent on the bed slope. I told you this point, YC is independent of the bed slope. Whether it is a mild or steep, YC value is going to be same. So here YC is going to be same. This is CDL. But whereas in the case of the steep slope, the NDL is going to be below the CDL. So this is NDL. You please observe this NDL line YN is dependent on or inversely proportional to bed slope and YC is independent on bed slope. Independent on the bed slope. That's the reason why. So wherever you see, whether it is a mild slope or steep slope, YC is going to be constant. But whereas in the case of the mild to steep, as bed slope increases, the normal depth is going to be decreases. So that's all, my dear. If you have understood this one, then you can answer this. So what are the conclusions that I have given? You see, flow always GV of a surface starts with NDL and ends with NDL. Now, as a layman, what I want you to observe is just you see mild slope. Mild means lesser slope. Lesser the bed slope, more the NDL. Followed by steep. Steep means more slope. More the bed slope, lesser the NDL. So this is one NDL and this is other NDL, and flow will take place from one NDL to other NDL, my dear. So from one end to other NDL, now the water surface should fall or should rise? Should fall. If you If you observe here, so this is an NDL and this is an NDL. Flow takes place from one NDL to other NDL, and from this NDL to this NDL, it should be falling or it should be rising, falling. And while it is falling, is it a second profile or is it a third profile? This is a second profile. So now you see how the flow is going to be happen. This is CDL and flow is asymptotic to NDL, perpendicular to CDL here, and then from here again perpendicular to CDL, asymptotic to NDL. Perpendicular to CDL and asymptotic to NDL. See, I am drawing a flow from NDL to NDL so that finally the flow is going to be uniform, and in between it is going to be gradually varied flow. In between it is going to be gradually varied flow. And what is this profile? This is M2 profile and this is going to be S2 profile. So can I say whenever a mild slope or whenever a lesser slope followed by a steep slope, whenever a lesser slope followed by a steep slope, then always the flow profile is going to be falling. Always the flow profile is going to be falling. Okay. So here what is the profiles? M2 and S2. And you observe over here, in this case, CDL, NDL is above CDL. In this case, NDL is below CDL. So I got two curves, M2 and S2. Simply it's drawdown, and while it is drawdown, it should be second profile. So M2 and S2. I hope you understood. So this is going to be the curvature. You can observe. Isn't the screen lagging? Is there? If it is there, please let me know. Because two three students are saying that there is a too much lagging in between. So isn't it lagging? Because my side internet is also good. Yeah, no. I mean, most of the people does not have any problem. So yeah, okay, fine. So I mean, only two people have been given that. Please check the internet because my internet connection is also good. Otherwise, I would have known that. So now this is a mild slope followed by a steep slope, and here I can say when a lesser slope followed by a steep slope followed by a steep slope, then always the profile is going to be falling at drawdown profile. Always GVF is a falling profile. GVF is a falling profile. So in the case of the lesser slope, when lesser slope followed by a steep slope, always GVF is a falling profile. This is one example. Now let me take this reverse. I'll give you some other examples also. Mild slope followed by the steep. Now let me take in a reverse way. B, if steep is going to be followed by mild, then as a layman you can directly say, Arey sir, layman, steep slope sir, steep slope means more slope, NDL is less. Next followed by mild slope sir, lesser slope, NDL is going to be more. So now from less NDL to more NDL, the flow should be rising or falling. Think and say. So now when a high slope is followed by the lesser slope, high slope means less NDL, lesser slope means more NDL, flow will be rising or falling? Rising. So always a profile is going to be a rising profile. Yes or no? But you know that how many profiles are rising profiles? Two profiles. What are those? First profile is rising and the third profile is also going to be rising. First profile is rising and third profile is also going to be rising. So now let's see what are those conditions. Okay. So now here this is a steep slope followed by a mild slope. So now in the case of the steep slope, first let me draw the serial. This is serial in both the cases. Serial is same. Now coming to the NDL. Coming to the NDL. In the case of the steep, this is NDL. In mild, this is going to be the NDL. So NDL and this is NDL. And here it is going to be serial and this is going to be the serial. Give me a minute, please. So now I am taking these two is I'm giving you two cases. So here I am going to say this is going to be case 1 and this is a case 2. Case 1 and here it is going to be the case 2. So now this is a steep slope followed by the mild slope. Let's see. In the case 1, why I am taking two cases you are going to observe. See, always I am telling you flow takes place from NDL to NDL. Yes or no? So now here this is an NDL, here this is an NDL. Okay. But this is a CDL, above CDL who is there? Subcritical. Below CDL who is there? Supercritical. Now I told you clearly, whenever a flow wants to meet from super to subcritical, then definitely there is a hydraulic jump. Yes or no? Yes. So whenever the flow wants to meet from supercritical to subcritical, from here this NDL to this NDL, definitely it has to cross the CDL, right? So whenever it is crossing the CDL, super to sub, there is a hydraulic jump. So what is going to be happen over here is first initially there is a hydraulic jump, and then the jump is going to be directly touches to the NDL. Means this profile is going to be directly touches to the NDL. There is no profile on the mild side. There is no profile on the mild side. So directly the water level touches the NDL, because eventually you know that finally flow has to touch NDL. Sir, what about What about like this, sir? What about like this, sir? Sir, if you draw this one, then what is this profile over here? This is second profile. What is the nature of second profile? Rising or falling? Falling. So can you rise over here? No. So what happens is directly it rises and reaches to the NDL. Finally, it is going to be the NDL. Whatever this profile is the S1 profile. You know that whenever the flow meets from less NDL to high NDL, it should be rising. It should be rising. So this is one possibility, my dear, where you can observe first there is a hydraulic jump followed by S1. Okay. Next, case number 2. Sir, you are saying there is a hydraulic jump, but for the hydraulic jump to happen, it requires some length. For the hydraulic jump to happen, it requires some length. If the length of the steep slope is less, now this is NDL, right? I can say the flow is going to be uniform. Up to this point. Now, it is going to be moving from steep to mild. Once it reaches to the mild, now listen clearly. In the steep, it is NDL only uniform. But once it reaches to the mild, it has to reach whom? NDL. Flow takes place from NDL to NDL. Now this is my NDL. I have reached this NDL. So in the mild, this is a third profile or not. So definitely water level will rise and perpendicular to CDL. But I have to reach whom? This NDL. So flow is crossing from CDL to NDL or not? Means again there is a hydraulic jump and then this is the flow. So you can see the flow is moving from super to sub again. So there is a hydraulic jump like this and the flow is going to be happens like this. So now what is the profile you are going to observe here? This is M3. So what are the possible profiles? When a steep slope is going to be followed by the mild slope? So I can say both S1 and M3 profiles can be possible, but doesn't exist at same time. What is the meaning of this? So S1 and M3 profiles are possible profiles. What are the possible profiles over here? But they don't exist at the same time. So because if there is S1, there is no M3. If there is M3, there is no S1. So it can be happen as S1, it can be happen as M3 based upon the length of the steep slope. Because if the steep slope is length more, then there is a hydraulic jump. If the steep slope length is less, there itself it won't jump and it won't rise. I hope you understood. So and here I can write one more conclusion as if a steep slope followed by a flat slope, GVF always rising profile. So S1 and M3 profiles possible but doesn't exist at the same time. So steep slope followed by a flat slope, GVF always a rising profile. GVF is always a rising profile. Okay. So now I hope you understood this. I hope you understood here. See, the common point that you need to know is, okay, when the flow is happening, is it crossing CDL from below to above? Is the flow is taking place from supercritical to subcritical? Yes. Below here, above, this is a subcritical. Below here, this is going to be the supercritical. So whenever the flow is going to be meet from the supercritical to subcritical, there is a hydraulic jump. That's it, right? So there is no wonders over here. And I'll give you some more possibles. And I give you some time. You please solve this. I'm giving you some more possibilities. Or I'll give you the figures directly. Come on. So these are some of the profiles I'm giving you. I want the answers. For all the three cases, I need the answer. Have some time for you and solve this. You know how to draw the milder mild? Milder mild means not horizontal. So don't take it as horizontal. So okay, so now I hope you got some answers. Now keep that answers with you. Let's see whether you are getting correct answers or not. So now first of all, mild to milder mild. The point number one that you need to consider is whatever the slopes are there for a given discharge, critical depth is same. Yes. So now you see in both the cases, mild. This is milder mild. What is the meaning of milder mild? Mild is less slope. Milder mild is very less slope. And you know that lesser the bed slope, more the NDL. Yes or no? Lesser the bed slope, more the NDL. First, for the mild slope, this is CDL. For the milder mild also, the CDL, critical depth is going to be same. So this is CDL and here it is going to be CDL. Now, let's come to the NDL. In the case of the mild, this is NDL. In the case of the mild, that is going to be NDL. Now, my dear student, you please tell me, this is NDL, yes. So when it is going to be NDL for a mild, now in the case of milder mild, whose bed slope is less than the mild, you know the bed slope is inversely proportional to normal depth. Yes or no? Lesser the bed slope, more the YN. More the YN means compared to mild, in the case of milder mild, the NDL is going to be more. The NDL is going to be more. Sir, why you have drawn the NDL for the milder mild is more, sir? Milder mild slope is less than the mild slope. So when a more slope is followed by a less slope, when a steep slope is followed by a flat slope, always the curve is going to be rising. Yes or no? And you know, flow always takes place from NDL to NDL. Now, by using that, this is one NDL and this is other NDL. Simply flow is going to be asymptotic to NDL, rises and meets horizontal to this NDL. So from here onwards, everywhere the flow is going to be NDL only. And what is this profile you are going to see? Only M1. The profile you are going to see is only M1. You don't see any other profile in the milder mild. Because why, sir? Is there any crossing of the CDL? Come on, tell me. Is there any crossing of the CDL? No. As you are not crossing the any CDL, you don't see any curve on the other side. You don't see any curve on the other side. Okay. So only one profile is going to be existing. What is this profile? M1. Similarly, let's come to the milder steep to the steep. And you know that in both the cases, CDL is same. In the both the cases, CDL is same. Okay. Now, what is a milder steep and steep? Milder steep means that is a steep slope only. What is the meaning of steep? So first I'll draw for the steep. For the steep, this is NDL. Now, what is a milder steep? See, milder steep means whose slope is less than the steep, or whose slope is flatter than the steep. Flatter the slope, more the NDL. So compared to the steep, in the case of the milder steep, see, his slope is steep only. Don't think the milder steep means sir NDL is above CDL. No, my dear. So here in this steep, and this is a milder steep. Milder steep means whose slope is less than the steep. And as slope is less than the steep, NDL is more than the steep. So now, if I draw NDL for the milder steep, this is NDL for the milder steep, and this is NDL for the steeper steep, means normal steep. And you know why I have given this one? Why? Simply the NDL means normal depth is inversely proportional to bed slope. Lesser the bed slope, more the NDL. Now again, see uh, this is a flat slope followed by a steep slope. Whenever a flat slope is going to be followed by a steep slope, always GF is going to be falling, right? So now if I draw the graph, so this is NDL and directly it meets the directly this curve is going to be meets the NDL. Directly this curve is going to be meets the NDL. So again, here it is going to be water level. This is the water level. What is the only profile that we are seeing here? The only profile that we are seeing over here. I'm sorry, this is the third profile. Oh, no, sorry. That's not the way. See, if I draw like this one, this is a third profile in the milder steep. So there's no possibility. So that's not going to be possible. Now you see. See, if I draw like this, then it is a third profile in the milder steep, which is not going to be possible. So the only possibility is the water level will come up to this point. Now, when it enters into the steep, now again, when it enters into the steep, now this is going to be the second profile. So as it is going to be second profile, it can be falling. So this water level is going to be false. What is this? NDL. Whatever this curve, this is S2. Whatever this curve, this is going to be S2. Because can you say the water level falls like this? No, because this is going to be the third profile. It won't be possible. So this is S2 and here it is going to be M1. I hope you are understanding the points. The points is you need to make sure the flow is going to be happen. Now coming to the adverse to steep slope. In both the cases, adverse to steep, this is CDL, and here it is going to be CDL. And in the case of the steep, this is going to be the NDL. This is going to be the NDL. So now, in the case of adverse, you know that the Yn is going to be infinity. From the infinity, you see, from the infinity to this NDL, it should fall. From the infinity to this NDL, it should fall. So when it is going to be fall, now the water level from horizontal, it is going to be falls like this, and from here onwards, perpendicular to CDL and asymptotic to NDL. So whatever this is A2 and this one is going to be S2. So please observe. Please observe this and you can get to know that. Why S3 is not possible? Are Babu, what is the meaning of S3? S3 means rising, but it is a falling. This is falling. Falling means S2 only. Whatever the falling, see always when a lesser slope followed by a more slope, it should be falling. What is the meaning of falling? Second profile or third profile? Second profile. So S2. Here it is falling from infinity because adverse means infinity, right? From the infinity to this NDL. So in the case of the adverse, Yn is infinity. So from the infinity to this NDL, it is going to be falling A2 and S2. I hope you understood. If you have understood this one, now I'll give you one thing. From there, you can understand it, complete concept. Okay. Yeah. Okay. First, here this is a mild, and this is from up to here. This is a steeper mild, and from here milder mild. This is a drop, and here is going to be the sluice board, which is partially open. So this is the condition. Yeah, come on, please solve. Solve this. Solve this. Mild, steeper mild, milder mild, and drop. I want you to get down the answer. I want along the length of flow, how many profiles are going to be happen? What are the possible profiles that you can see? If you are going to understand this one, then you can understand anything. I'm telling you that. First, you have to draw those lines. The dotted lines should be there. Okay. So now you know the meanings of all these things. Then I want you to tell me what are the type of profiles that you are going to see along the length. You know the concept means you know the logics also. What is the logic? Logic: lesser slope followed by more slope, lesser slope followed by more slope, lesser slope, more NDL, more slope, less NDL, falling, and more slope followed by less slope, rising. Whenever there is a sluice gate on the back of it, rising, and in the bottom, vena contracta, and then it is going to be rise. And whenever there is a drop, the water level is going to be fall. Yes? So come on, if you have understood that, you please tell me the answer. What is 65? No. You see, in all the cases, the serial is going to be same. Yes. So as a serial is going to be same, let's first represent the serial. Whatever the red dotted line I am drawing here, here nothing but serial. Here also it is going to be serial. Yes. Now, first of all, mild. First, mild. What is mean by mild? NDL is above than the serial. So first you draw the NDL for this. This is NDL in the case of the mild. Now, what is mean by steeper mild? Steeper mild means is not a steep slope. Keep that in your mind. That's steeper mild means the steeper mild slope is more than the mild slope. The more the bed slope, less the NDL. More the bed slope, less the NDL. So compared to the mild, the steeper mild NDL would be less. The steeper mild NDL would be less. Okay. Now coming to the milder mild. See, milder mild slope is very less than the mild slope. Yes or no? Milder mild slope is less than the mild slope means its NDL would be more than the mild or not. Now for the mild, this is the NDL. For the milder mild, now the NDL is going to be looks like this is going to be the NDL and this is the NDL. And here this is the NDL. Okay, so now you tell me, you know that flow takes place from NDL to NDL. Flow takes place from NDL to NDL. Now everybody, in the case of the first mild to steeper mild, I know that when a lesser slope followed by the more slope, lesser slope, more NDL, more slope, less NDL, always is falling. So water level, you see here, this is the water level. It falls and reaches the NDL directly. It falls and reaches the NDL directly. Okay. But is it going to be end there? No. Is it going to be end there? No. Now this steeper mild is going to be followed by the milder mild. So this NDL should have to meet here. Now for here, the flow will be somewhere normal and then it starts to rise and reach the and reaches the NDL. Okay. Now it reaches the NDL. So this is the rise. And now due to this obstruction, see, if there is no obstruction over here, then the flow is going to be NDL. Keep that in your mind. If there is no flow, then the flow is going to be, means there is no sluice gate, then the flow should be the NDL. But due to sluice gate, you know that the water level is going to be rises. And now the water level is going to be rises like this. The water level is going to be rises because of due to whom? Sluice gate. If there is no sluice gate, the flow would have been stopped by using the NDL as a uniform flow. Now due to sluice gate, it's an obstruction. The water level is going to be rises. And now through the bottom of the sluice gate, the flow first falls and forms a vena contracta. Vena contracta. Yes. So there is a vena contracta. And then it has to rises to whom? NDL. For rising the NDL, what is going to be happen is it rises and then there is a hydraulic jump. There is a hydraulic jump and immediately after that jump, the water level, see, this is going to be, see, this is drop or not. As it is a drop, the water level falls. The water level is going to be fall. You can observe here, immediately after this, what is going to be happen is the hydraulic jump is going to be rises. So you can observe the jump is going to be rise like this, and then this water level is going to be rise and immediately it is going to be fall. So this is the water level. I hope you understood what is happening. So first of all, let me repeat this again. You see, first of all, mild slope is followed by steeper mild, NDL to NDL falling, and then steeper mild to mild, milder mild, NDL to NDL rising. And as it is a sluice gate, further the water level is going to be rising, and then through the sluice gate, so finally it has to reach NDL or not. So for reaching the NDL, there is going to be third profile, and then there is a hydraulic jump, and due to this drop, water level is going to be fall. So how many profiles total here are? This is here M2, and this is total as M1. Everything is rising or not M1, and this is M3, and here it is going to be M2. So possible profile sequence is M2, then M1, then M3, and hydraulic jump is there, and then M2. This is the possible profile sequence. I hope you understood this. If you have not understood this, then you please go back to the basics, and you can understand much more better. See, I'm not taking too many points over here into the consideration. I know flow takes place from NDL to NDL. That's it. I know flow always goes with the NDL to NDL. So just to draw lines by keeping in your mind, this is a second profile falling. This is the first profile rising. First profile rising. Now coming to the third one. So this is going to be the third profile, and then there is a hydraulic jump, and then there is a water level fall. Okay, I hope you understood this. M1 will be 2 times, means you are going to give M1 as only one M1. M3 behind sluice gate M1 profile occurs. Yes, this is M1. No? See, the total is M1. This is also M1 only. The total is M1. You cannot write M2, M1, M1. The total one curve, one single curve, this is M1 only. Okay. I'll write some here. This total curve is going to be M1. The total curve is going to be M1. And below the sluice gate, you know, immediately the water level is going to be false and forms vena contracta. Vena contracta. So this is vena contracta. And then you know that the flow has to meet the NDL. So if it wants to meet the NDL, it should rise and forms hydraulic jump, and then water level is going to be formed. So still, if you have any other doubts, you can ask me now. I hope the profile topics are interesting for you. There are no many here. If you feel these are too many, then you are going to be many. There are no too many. I just focused on one point. The point is, you see, what are the conclusions I made? GVF surface starts with NDL and ends with NDL. That's one point I have been focused. And the other one is going to be like, so left slope followed by a steep slope, GVF is a falling profile. And when a fluid steep slope followed by a flat slope, GVF is always a rising profile. If you know that, then you can understand much more better. Okay, I hope you understood this. I can directly say without drawing this one, or a mild, steeper mild. Okay, mild to steeper mild means lesser slope to more slope. Lesser slope to more slope means falling. What is the only falling? M2. Okay. Next, steeper mile to milder mile. Steeper mile to milder mile means more slope to lesser slope, which means rising. What is the rising profile of mild M1? Sluice gate is there. Next to sluice gate, what is going to be happen? M3. There is a hydraulic jump, and due to this drop, due to that drop, what happens? Water level will fall. M2. That's it. Okay. So this is about the combination of the slopes. This is about the combination of the slopes, and here also I mentioned a small points only that you can understand. So here, see, the concept is critical. I'm giving you too many examples so that you can understand much more better. And now, control sections. Control sections. Is Louis is assumed to keep below CDL? Yes, we are assumed to keep below CDL. If there is a sluice gate for steeper slope, there won't be any hydraulic jump. Yes. Okay. Control section. So now, what is a control section? Control section means a section where there is a definite relationship between depth and discharge exists. Where there is a definite relationship between depth and discharge is going to be exist. Or a section which is away from the disturbances. A section which is away from the disturbances. Okay. Sections. Section at which definite relationship between depth and discharge exist. Depth and discharge is going to be exist. So what is the meaning of this one, sir? For example, let me take a, so this is a mild slope. Let me take this is a mild slope. Okay. And you know, in the case of the mild slope, on the back of an obstruction, you can see the curve is going to be like this. Yes or no? So this is going to be asymptotic to NDL, and this is going to be asymptotic to horizontal. Okay, M1. Don't ask me, sir. Now, don't ask me how this curve came, because I have given you many reasons and I explained that from the basic point of view. So this is a uniform flow, and this is nothing but the gradually weld flow. Yes or no? Yes. So now my question is, you see, in the case of the GVF, question number 1 for you, can you find out the depth over here? This is rising, right? You cannot find out the exact depth. Can you know the depth over here? No. But you see, this is a horizontal asymptote or not? Yes or no? That's a horizontal asymptote, and I can know that whatever the depth of water just on the upstream side of an obstruction. I can find out the depth of water on the upstream side of the obstruction by knowing the height of the weir, and by knowing the head of water above the weir. So what is the total depth of the flow just on the upstream of an obstruction? H plus Z, where Z is the height of the weir and H is the head of water above the weir. Yes. So now you can see this is the section where I know the depth. If I know the depth by using the Manning's equation, can't I find out the discharge? Think and say. And do you know the depth over here? Do you know what is the depth over here? But you know this is a depth. But what is this depth? This is normal depth. This is uniform flow, my dear. This is uniform flow. So GVF is going to be start from here to here. In a GVF water surface, wherever you see there is a definite relationship between depth and a discharge exists, Such sections are known as control sections. Such sections are known as control sections. Okay. So now, how can I predict this control sections, sir? Just number one, depth and discharge is going to be exist. Wherever there is a depth and discharge is going to be exist, that's going to be the control section. So now, the other point is, let's go back to the whatever the discussion I have made. Everybody. Okay. So these are all the things that I have been explained so far and so good. From the starting onwards, you can say where the hydraulic jump is, means where the control section is going to be happen. Okay, now you see, my dear, everyone stop your writings and listen to me. Okay. So now, in the case of the M1 profile, you know the exact depth at this point, yes or no? And whatever this point is known as a control point or control section, represented with C. Whatever this section is known as a control point or control section, because at this point it is going to be asymptotic to horizontal, so I can find out the vertical depth. But do I know the vertical depth over here? Do I know the vertical depth over here? No, I don't know the vertical depth over here, my dear, but I can find out the vertical depth over here. Now, next, come to this graph. If you see this graph, okay, listen to me carefully again. From here onwards to here, the water level depth is going to be falling. Yes or no? Can I find out the depth over here? Can I find out the depth over here? No. But you know that. At this point, you see, at the downstream side, you see, at the downstream side, what is the depth of flow here? At the downstream side, the depth of flow is going to be YC. Once you know YC, can't you find out the relation between YC and discharge? YC is equals to Q squared by G whole to the power of 1 by 3. So you need to find out a section where you can definitely know the depth, and from there you need to find out the relation between depth and discharge. So in the case of M2 profile on the downstream, I know the depth YC, and once I know YC, can't I find out the discharge? Yes. There is a definite relationship between the depth and discharge. So now this is going to be the control point C. This is going to be the control point C. Now, let's go with the one more figure over here. Okay. So in the case of the M3 profile, listen to me again over here. Listen to me. In the case of the M3 profile, now you see the hydraulic jump is going to be created over here. When the hydraulic jump is going to be created, you don't know the exact depth over here. Okay. But if you see the starting point, you know this is at vena contracta. Yes or no? At vena contracta, by using a coefficient known as CC, coefficient of vena contracta, that we will be discussing the means already if fluid mechanism has completed, you have been discussed. So coefficient of vena contracta is nothing but whatever the area at vena contracta by area of opening. My dear, if I know the depth of flow at the area of opening, whatever the depth of vena contracta, so depth at vena contracta by depth at the opening. You know the depth at the vena contracta. Once I know the depth at vena contracta, in the flow measurements we have some formulas. I hope you may remember Q is equals to root 2 GH into CD into H to the power of 3 by 2. So some equations are there. So there you are going to determine the relation between the depth and discharge at this section. This is the control section C. So I hope you understood. See, in this case, you can find out the control section here. And in this case, you can find out the control section here. And in this case, you can find out the control section here. Point number 1. Wherever there is a definite depth and relation between discharge exists. 2. Sir, I don't want to go with the depth and relation, sir. Can you make it further simple? Yes, I can. The sections which are away from the disturbances. The sections which are away from the disturbances are known as control sections. The sections which are away from the disturbances are known as control sections. Okay. Let's go over here. How does M1 profile is going to be happen? If this is a weir, the flow will hits and rises, and see the flow will hits and rises, and this disturbance will travel towards the upstream side or downstream side. Repeating again, this is a weir. What I'm showing you here is nothing but the weir. So this is a weir. My hand is going to be the weir, and a flow of water coming towards my hand. So this water gets hits, and immediately water level rises. And after rising, this disturbance will be there or will travel away from the obstruction, or this disturbance will travel towards the upstream. So this will hit and this disturbances will travel towards the upstream. And the disturbances travel towards the upstream means downstream is a section where it is away from the disturbances are not. Yes. So here, the downstream section is a section where the disturbances are going to be least. Now, next point. You come over here. This is M3. M3 after who is there? Hydraulic jump partner. After M3 who is there? Hydraulic jump. So after M3 there is hydraulic jump, and hydraulic jump will create disturbance or not? Yes. For M3 this is upstream and this is going to be the downstream. For M3 profile, upstream and this is going to be the downstream. Okay. So on the downstream of M3 there is a hydraulic jump. On the downstream of M3 there is a hydraulic jump. So this M3 has upstream which is away from the obstruction or which is away from the disturbance. So this is going to be the control section. The next point is point number 1. Controls sections should be away from disturbances. Now, third point is hydraulic structures like weir, sluice gate acts as control sections, and wherever critical flow occur, or you don't need to find out this one. So hydraulic structures like weirs or sluice gates are going to be acts like a control sections. And now the last and final point, which make sure you can understand for rest of your time, is whenever the flow is subcritical, always control section locate on the downstream side. If the flow is going to be subcritical, control section locates on the downstream side. Okay. Yes. Now the final point is, in subcritical flow, control section locates on downstream side. In subcritical flow, control section locates on downstream side of GVF, and in supercritical flow, control section locates on upstream side of GVF. So if it is a subcritical flow, it should be downstream side of the GVF, and supercritical flow, it should be upstream side of the GVF. I have lots and lots of profiles. Now I am going to check you with that. Have a look. Starting with the M1. Okay. Is it a subcritical flow or supercritical flow? Come on, tell me please. Is it a sub or super? Above serial. This is a subcritical flow. For the subcritical flow, M1 profile, does the control point is locating on the downstream side or upstream side? Downstream side. Okay. Now this is M2. This is above serial, which is still subcritical. And for the M2, as it is a subcritical, control point should locate on whom? Downstream side or upstream side? For the M2, this is the downstream side. So this is going to be the control point. Is the control point. Okay. Understood or not? Where C represents a control point R section. Okay. Next, come to the next one more figure. This is M3. Is it subcritical or supercritical? Supercritical. In the case of the supercritical, who is going to be the see, this is M3. In supercritical, upstream is going to be the control point. Upstream. This vena contracta is going to be the control section. In the case of the supercritical, for M3, right? For M3, this is M3, this is upstream, this is downstream. What is upstream? Vena contracta. Similarly, now let's go with the S1, S2, S3. You see, for S1, for the S1, so this is sub or super, this is subcritical, the control point is on the downstream side for S1. Now coming to the S2, S2 is a supercritical, right? For supercritical, control point should be on the upstream side. So this is the control point. That is the control point, because for S2 this is going to be the control point, right? And moreover that at this control point you can see what is the depth, please. This depth is going to be YC. Whatever this depth, serial, this depth is going to be YC. So when there is a YC, I can find out the relation between depth and discharge. So now I am saying you for S2, this is a supercritical. Supercritical means upstream. Subcritical means downstream. You see, this is subcritical, control point is on the downstream. This is supercritical, control point is on the upstream. I hope you understood. Yeah. Similarly, here, now you tell me, this is again a supercritical, my dear. As it is again a supercritical, then for the S3, the upstream is going to be the control section, where this is nothing but vena contracta. So vena contracta acts as a control section. Okay. Similarly, now let's go with the combination of slopes. Now again, here M2 is subcritical. For M2 subcritical downstream point, this is the downstream point as a control point. For S2, S2 means supercritical. For the S2 upstream, for the subcritical M2 downstream, S2 upstream. Next, similarly here for S1 subcritical control point, this point. For M3, M3 is a sub or super? M3 is sub or super? Super. M3 means supercritical. And you can see this is nothing but the control point. And you observe for this, the control section, whatever, this is nothing but control section. And here both are going to be same or not? The section, this is a section where control point is locating. In both the cases, control section is same. Yes or no? And then you come over here again, M1. M1 is subcritical or supercritical? Above serial, above serial, that's subcritical. So this is going to be the control point C. For NDL, now S2 is supercritical. This is the control point C. And here A2 sub, because above serial, control point, S2 control point. And here if you come over here, now you tell me M2 is going to be above serial, downstream side control point. This is a control point. And again M1 and M1, you see whatever this are, just upstream of an obstruction. Upstream of an obstruction, this is going to be the control point C. And this is the control point C. And then for M3, this is the control point C, because vena contracta, right? This is the control point C. And finally, this control point, that's it. Because you see, I'm just believing one point as if, what about the control point? In the case of the subcritical flow, control section locates on downstream side. In supercritical flow, control section locates on the upstream side. That's it. If you know that, you can say the control sections. Whatever the figure you take everywhere, keep the control point on downstream. Super, keep the control point on upstream. I hope you people are understood. I hope you are enjoying my classes, and if you have any problem with my teaching, you can let me know. You can let me know. I hope you are able to understand the classes well. No, I cannot stop here, but still a half an hour is there. I gave you 2 breaks, yeah, and I have given literally 50 minutes of break. 50. 50 minutes of break. So now let's see the next, the last topic in the GVF. The last topic. See, I said the 3 objectives in the GVF is number 1, whether to know the given profile is rising or falling by means of dy by dx. Whether it is rising or falling. Number 2, whether to know the curve is going to be convex or concave. Now the third one, the last one in the case of the GVF is last one, the last topic. It won't take much time. Length of GVF. Length of GVF. So what is the length of the GVF? Now, just now I'm taking an example. You know, this is a GVF profile from here to here. This is a GVF profile. Now I need to find out what is the length of the GVF. What is the length of the GVF? See, for example, you take definitely here, whatever the depth of flow at this point, let's take this depth as a y1, and depth of flow at this point, both are different. Yes or no? Depth of flow at this point y1 and depth of flow at this point, both are going to be different. Now I need to know what is the length. See, what is the definition of the gradually varied flow? First of all, the definition of the gradually varied flow itself is, the definition of the gradually varied flow itself is the variation of flow happening over a longer length. So if the variation is going to be happen over a longer length, then we need to know what is the length of that profile. We need to know what is the length of that profile. Okay, so now let's see how to find out the length of that profile by taking a small element, my dear. By taking a small element. Okay, so let's take a small element dx. Let's take a small element dx. This is a small element whose length is going to be dx. Length of the element is going to be dx. Okay. So now, you know, at any section, you can write down the total head as h is equals to v square by 2g plus y plus z. V square by 2g plus y plus z. Okay. At any section, the total head is equals to v square by 2g plus y plus z. Now, I need to find out this length. So this is small dx, and the total is going to be, let's take it as delta x. Okay. Now, can I write this y plus v square by 2g as a kinetic specific energy? What is the specific energy, my dear? Potential head plus kinetic head is nothing but the specific energy. So from here, can I write h is nothing but y plus v square by 2g specific energy plus datum head as j. Now, I want to find out the length. So what I do is differentiate with respect to x on both sides. Differentiate with respect to x on the both sides. So this method is known as a direct step method. So differentiate with respect to x on the both sides. If I differentiate, then dh by dx is equals to de by dx plus dz by dx. I hope you remember, in the case of the starting of this GVF, I want to provide some small slope, so that's the reason why I erased. So in the case of the starting of the GVF, I have taken this dh by dx as a minus sf. Remember, d by dx plus this dz by dx as a minus s naught. If you have remembered that, you go back to the dynamic equation of the GVF. There I said that dz by dx is a minus s naught, dh by dx is minus sf. Now, you can write this d by dx is nothing but s naught minus sf. S naught minus sf. Okay. Now, this dE by dx is nothing but s naught minus sf. What is dy by dx? S naught minus sf by 1 minus f r square. Let me take this as 1 and let me take this as r. Now, from 1 and 2, can I write dE by dx is equals to dy by dx into 1 minus fr square. 1 minus fr square. So dE by dx is equals to dy by dx into 1 minus fr square. So now, from this equation, there was one previous gate question and IES question also. So the question was, listen and tell me. Question: d by dx is positive when option is A, flow is subcritical and rising profile, B, flow is subcritical and falling profile, C, flow is supercritical and falling profile, D, flow is supercritical and rising profile. So these are the options made. Now you see, I want to say when the dE by dx is going to be positive. Now let's go back to the equation. So you know that the solution is d by dx is equals to d by dx is equals to s naught minus sf. Then I can write as a dy by dx into 1 minus fr square. 1 minus fr square. Okay. So now you know when this dy by dx is going to be positive. When dy by dx is positive and Froude number is equals to 1 less than 1. When dy by dx is positive and Froude number less than 1. So if dy by dx is going to be positive and fr less than 1, 1 minus less than 1 positive, positive into positive, positive, positive into positive, positive. Okay. So that is one case. Other one is dy by dx is going to be negative. What is the meaning of dy by dx negative? Falling profile. What is the meaning of dy by dx negative? Falling profile. And if I want to make sure d by dx as a positive, and if dy by dx is negative, then fr should be more than 1. When fr is going to be more than 1, 1 minus more than 1 negative into, if dy by dx is going to be negative, negative into negative, it is going to be positive. So now when the d by dx is going to be positive, if dy by dx and fr, if dy by dx is positive and fr less than 1, fr less than 1 means a subcritical flow or supercritical flow? Subcritical. D by dx is going to be positive when flow is rising. Yes, sir. So solution is d by dx is positive A, flow is rising. Rising means dy by dx is positive. Dy by dx is positive and subcritical and subcritical. What is the meaning of subcritical? fr less than 1. So this is one case. Flow should be rising and subcritical. Flow is falling. Falling means d by dx is negative and supercritical. What is the meaning of supercritical? fr is going to be greater than 1. When fr greater than 1 square, greater than 1, 1 minus greater than 1, negative, negative into negative, positive. So what are the options? Flow is subcritical and rising. Answer A. Flow is supercritical and falling. Answer C. So answers are A and C. These type of questions can be asked for the MSQ. These type of questions can be asked for the MSQ. See, especially if you get an MSQ in open channel flow, you get the MSQ questions, multiple select questions in GVF. Because they are giving, they are going to be give you they give you some profile and they will ask you what are the possible profiles. What are the possible profiles? For example, you see this is one of the question. Is it? Yeah, this is one of the question. So I can give you this question and I'll ask you what are the possible profiles. So you have to keep all the profiles, right? M2 is possible, M1 is possible, hydraulic jump is possible, and M3 is also going to be possible. Okay. So now this is one of the previous GATE and IS question. I have modified that question. I gave all these options to make sure what are the correct answers. Okay, this is dy by dx. Yes, this is dy by dx. Okay. So now, but that this is not what I want. I want whom? Delta x, right? I want whom? Delta x. So now, from this, I'm going to get as where again dE by dx is equals to S naught minus SF. S naught minus SF. Now, if you integrate on the both sides, then delta E by delta x is nothing but S naught minus SF bar, where delta x is equals to delta E by S naught minus SF bar. And this is going to be modulus. What is the meaning of modulus? Modulus means whatever the value that comes inside, that should be taken as a positive only. If negative comes, modulus of negative is going to be positive. Where finally, this is a single step. This is a single step or direct step. Single step or direct step. Delta x is equals to delta E by S naught minus SF bar, where delta E is a difference in specific energy, which means delta E is equals to E1 minus E2, and S naught bed slope, SF bar means average or mean energy slope. Average or mean energy slope. So what is SF bar? Average or mean energy slope. Okay. Now, what is how to find out this SF bar, sir? This SF bar is equals to SF1 plus SF2 by 2. Sir, first of all, how to find out this SF bar? You know, right? How to find out the SF? You know how to find out the SF. From the Manning's equation, we have solved already two problems. For previous gate question and one of the classroom practice question. I solved how to determine the SF from the Manning's equation. So from Manning's, you know, Q is nothing but A into 1 by N into R to the power of 2/3 into S whole to the power of 1 by 2. Yes or no? Now, if it is a GVF, you know Y is equals to Y and S is equals to SF. If it is a GVF, you know Y is equals to Y and S is going to be SF. What I required is SF bar, right? Then Y becomes Y bar. And what is this Y bar, sir? This Y bar is the average depth of flow, which is nothing but Y bar is equals to Y1 plus Y2 by 2. Y bar is equals to Y1 plus Y2 by 2. So once I know the Y bar, Y1 plus Y2 by 2, then I can substitute this Y bar in this equation. I can find out SF bar. Once I know the SF bar, S naught and delta E, I can find out the delta X. Okay. So I hope this is just a formula. Delta X is equals to delta E by S naught minus SF. This topic is very important for the mains, ESC mains. In ESC mains, they ask most about these questions. So you don't need to worry about that. Yeah, you can have this. So that's all with the GVF. And this one, whatever this direct method, it is suitable for note. Direct method is suitable for prismatic channels only. Prismatic channels only. Okay. So that's about the how to find out Y bar means they give the Y1. You see, if I want to find out the length, this is Y1 and this is Y2. Find out the average depth. Y1 plus Y2 by 2. So why not for the other channels is see the curve is going to be, this is is it a linear or a curve? This is a curve. And how come the average is going to be Y1 plus Y2 by 2? That's the biggest limitation. The biggest limitation is the Y bar cannot be Y1 plus Y2 by 2. But we are making this one as a linear and the average is going to be Y1 plus Y2 by 2. So the finally, how to determine the delta X, delta E by S naught minus SF bar. And how to find out SF bar? Find out the average depth of flow, substitute in the Manning's equation, find it out. Okay. So I hope you understood this. Now, Let's see a problem behind this. So that's all about today, and we completed most of the OCF media. That's see, we completed a study uniform flow, we completed a study non-uniform flow, and non-uniform flow GVF, and then the remaining two topics that we are going to do is study non-uniform rapidly varied flow, hydraulic jump. Study non-uniform rapidly varied flow known as hydraulic jump, and unsteady non-uniform rapidly varied flow. So steady state non-uniform rapidly varied flow is a hydraulic jump. Unsteady non-uniform rapidly varied flow is a surge. These are the two topics left over. So those two topics it will take 4 to 5 hours, the remaining, and possibly we may complete, I'm telling you, we may complete. So this hydraulic jump and surges by tomorrow and after tomorrow, which means we may get a 2.5 hour session, right? So Monday and Tuesday, we're going to get 2.5 hour to 2 hour 45 minutes a session. So tomorrow and the day after tomorrow, we will be completing the open channel flow. And then we are going to discuss about the dimension analysis. For the dimension analysis also, it will take 2 days for the dimension analysis. So 2 days are, it will take around 4 hours. So it may complete it Tuesday, no, Monday, Tuesday, and Wednesday, we are going to start the dimension analysis. And Thursday by first 1 hour, or let's take the total Thursday is going to be the dimension analysis. So possibly in the next 4 days, means Monday and Tuesday, we discuss about hydraulic jump and surge. That will be completion of the open channel flow. Wednesday and Thursday, we are going to discuss about the dimension analysis. That will be completion of open channel flow plus dimension analysis. That's the end for the gate students. For the end for the gate students, and for the ESC people, there is a one more chapter extra, flow measurement devices, that we'll be discussing on Friday and Saturday. Friday and Saturday, the 2 classes would be there. So that's also one chapter. For the 2 classes, we are going to discuss about the flow measurement devices. So the time that we are going to spend for the gate people is the next 4 days we are going to spend. As you know, this geotech means this subject is not as long as geotech. I spent 38 days with you for geotech, and I think today is the 9th day, 9th or 10th day, somehow. I hope so. This is the 10th day. So within 4 days, we are going to complete the open channel flow. And I want you to solve this question on your own. I don't do now. I'll do it tomorrow class. But meanwhile, you have to look over that. I'll stop the session now and I'll go with the doubt clearing sessions. Because I know mostly a lot of people might be having some doubts. So let's clarify those doubts. Yeah, this 19th question, and see, this is 20th question already done. 20th question is already done. We have done. See, this 20th question just now I have been mentioned, right? So whatever the given question, M2, M1, M2, sorry, M3 and M2. So M2, M1, M3 and M2. Just now we have done this question, and 21 we have done. You please go through this 23, question number 23, and that's it. This is the only one question. You please go through this question as a homework. I'll attach this one in the PDF also. This is a homework for you. Please try to solve. That's a very good question. You need to understand the question very clear to make sure that question. So I hope you can solve this one. This is the only question I am going to give. That's all with the GVF, my dear. That one question that I'll be solving in the first hour of tomorrow. So those who can solve, you solve it today. Now let's start a doubt clearing session. And those who wants to leave, they can leave. Yeah. Yeah, there is a one added topic in the geotech. There is a lateral loaded piles that will be discussed. Okay, fine. So now I'm going to open the doubt clearing session. Those who have doubts, you please raise your hands. Mr. Naresh, please speak out, Naresh.
Am I audible, sir?
Yeah, you're audible to me. Tell me.
So the question we solved, sir, gate 88. I
Gate.
have doubt. Yeah, in 1988 it was maybe. Before this.
Gate 88.
Yes, sir.
This one, you are telling me?
Yes, sir.
Hmm.
Sir, here which slope we have considered, sir? Mild slope or sir steep slope?
Mild one. Because of this a long prismatic channel is, see, generally, one question we have done. Have you remember that? So one question where they asked what is the depth on the downstream side of a free fall condition?
Yes, yes.
We called Y1, Yn, Yc, and we got it as a mild, and we find it as a Yc, right?
Yes, sir.
If there is a long prismatic channel, long channel slope should be less. Okay.
Okay. Sir, what would have been the case if it would have been the steep one?
If it was given the steep, see for the given the steep one, see just if this is steep slope, then
Yes, sir.
above is going to be CDL, below is going to be NDL. Yes or no? Yes or no? So if you draw the graph, then the flow will be looks like this. Then how come the flow fall like this? Do you think so?
Hello.
If it is a steep, this is CDL and this is NDL, right? Hello.
Am I audible, sir? Hello.
Yeah, you are audible to me.
Sorry, sir. It was some network issue. I had a call just. Sorry, sir.
Okay, fine.
So can
So
you
in
please
the
explain
case,
it once? That steep one.
yeah. So in the case of the steep slope, you see the CDL is going to be above and NDL is going to be below, right? Yes. So if you draw the graph for this, if you say the fall drop, then it should be asymptotical to NDL. Yes or no? Now, do you think water comes over here and falls something like this? Hello? 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 I hope, Mr. My dear, you lost the connection. So, sorry for that. Now, let's go to the next person. Pavan Kalyan. Come on, Pavan Kalyan, tell me.
Hello, sir.
Yeah, Pavan Kalyan, tell me.
Sir, can you take S1 profile where you have explained the example, practical example?
Yeah, tell me.
Sir, in this, we have taken that at the end, the water level will be above the VL node, sir,
Yes.
at the control section.
Yes.
Can the rate of flow be such that that final water depth can be between CDL and NDL?
No.
It cannot occur, sir.
No.
Why, sir?
Velocity is going to be changes.
Okay,
Once it is obstruction, the kinetic energy will dissipate. Dissipate means it will convert to potential energy.
yes, sir. There will be some increase in potential energy, but will it be higher than the CDL?
Will it be higher than the CDL? Means will it be?
higher, like that potential energy will be increasing now, sir.
Yes.
So this increase in potential energy, will it be more than that CDL?
Yeah, more than the CDL only. That's what. Now, that is the meaning. More than the CDL only.
Okay, sir.
Okay.
And then, sir, one more doubt, sir.
Yeah.
Sir, can total energy line be non-linear?
No, it's not. Yeah, it can be non-linear. It can be non-linear.
Okay. Like in our analysis, we are taking it as linear, sir.
No, in our analysis also we are taking non-linear. At a particular section we are taking. We are not taking along the section. Along the section, no?
Okay.
Why I am taking as an average slope here? You tell me.
Sir?
I am taking here as an average slope, no?
Yes, sir.
Average of mean energy slope. Why I am taking average of mean energy slope?
Okay, it is changing.
If the total energy line is linear, then I don't need to take that. Yes or no?
Yes, sir.
If the curve is going to be like this, then I have to take two different specific means
Yes, sir. Yeah.
and I have to take average.
Okay.
Yeah.
Fine, sir. Thank you, sir. That's it.
Mr. Vishnu, please speak out.
Hello, sir. Am I audible?
Yeah, you're audible to me, Vishnu.
Sir, I have little confusion in this mild and milder and steep and steeper. How can
What's
we
your
identify?
confusion?
That means mild steeper means which one, sir? Really?
Mild?
Mild steeper.
It's not mild steeper, milder steep. See, I'll tell you one thing. What will be your weight? What's the weight of yours?
Sir, 65.
65. Okay, you're too lean, man. Mine is 93, so I cannot compare with you. Okay, fine. Yeah. See, 65. Your weight is a 65.
Yes, sir.
65 is less compared to me. Okay. But 65 is more for a guy who is 50 kgs. You
Okay.
are 65 kgs, but I am telling you, you are leaner than me and you are fatter than some person who is going to be 50 kgs weight. Okay.
Okay.
Here that lean or fat is comparative or relative comparison. Yes or no? Means I am
Yes.
comparing you with myself and I am saying you are lean. And I am comparing some lean guy and I am saying you are going to be fat. So similarly here, the meaning of a steeper mild is, the meaning of, listen to me. The meaning of steeper mild means compared to the mild, if the slope is going to be more. If the bed slope is going to be more, then we call it as a steeper mild. Understood?
Okay, sir.
And if I say milder mild means compared to the mild, the slope is going to be less. Then we say it as a milder mild.
Okay.
Yeah, it's all about those slope points only. See, whatever that comes, milder mild means the slope is mild. The slope is going to be mild, which means NDL is more than CDL. Okay.
Okay, sir.
Its actual bed slope is less than the actual mild slope.
Okay, sir.
Okay.
Okay, sir.
Anything else?
Nothing, sir. Thank you, sir.
Now next, Mr. Shubham. Mr. Shubham, please speak out.
Hello.
Mr. Shubham. Yeah, Shubham, tell me.
Sir, in case of adverse slope,
Yeah.
why n is infinity?
What is the meaning of S naught positive?
What, sir?
What is the meaning of Y naught or Yn positive? Means S naught positive. S naught positive means is rising slope or not?
Yes, sir.
What is the general condition of open channel flow? Flow always takes place from higher datum to lower datum or not?
Yes, sir.
Here, when the slope is going to be increasing, the datum is going to be from low to high, right?
Yes, sir.
So such type of slopes are going to be used to store the water.
Okay.
Whenever you store the water, whatever the water you add, that can be stored, right?
Yes, sir. Means flow will not reach uniform flow.
The meaning of Yn is equals to infinity means whatever the water you added, okay, whatever the water added, it will be there.
Okay.
That's
Okay,
the
sir.
reason why. That's the reason why we said infinity.
Okay. Thank you, sir.
Yeah. Next, who else are there? Nobody is there. Very, that's it. That's about today's. What is this, man? So most of the students have understood then. Mr. Naresh, you have already spoken, right? Mr. Ash, Mr. Ash Kondawar, speak out.
Good afternoon, sir.
Good afternoon, Ash.
Sir, in case of that one-step calculation of the length,
Yes.
sir, if the difference between that both depth is means more,
I did not get you.
say the difference between y1 and y2 is more, means
No,
long length of a channel,
it won't be more.
it won't be more.
Yeah, the variation is very less, my dear. In reality, I can say the gradually, if there is a gradually varied flow, for a layman, they cannot predict that there is a gradually varied flow. Such a very variation. Like, for suppose somewhere wherever we are standing at that section, suppose let's say 1.5 meters of depth would be there. Okay. And 1 kilometer down of the section where we are, 1 kilometer downside, the depth may be 1.6 or 1.7.
Okay.
You see that slope. See, over 1 kilometer length, 1.5 to 1.7 is only 0.2 meters, right?
Yeah.
So such a very, very, very less variation. See, whatever the realistic flow, I am showing you some profiles over here, right? I am showing you by exaggerating them. So this curve is going to be falls like this and rises like this. But if you solve the questions, we have solved some questions now, dy by dx values.
Yes.
Where you can see that dy by dx, one of the question I can show you, one of the previous gate question we have solved, right? Yeah, you see this? What's the dy by dx we got?
0.00312 small.
What is the meaning of 1 by 00319? That's going to be 0.00319 means that's going to be 1 in 313.47. Yes?
Yes, sir.
What is the meaning of 1 in 313.47?
In a stretch of that
300 meters, you have to see 1 meter rise. Yes?
Yeah.
So 300 meters length, 1 meter rise, that's very, very, very less, right? That slope is dy by dx variation is very, very small that we cannot predict with our human eye. That's the reason why we are going for that analysis. Okay.
Okay, sir. That's why we are assuming linear variation.
Yeah. Yes.
Okay, sir.
Okay.
Thank you, sir.
Mr. Sai Mahesh.
Hello, sir.
Yeah, Sai Mahesh, tell me.
Sir, can you open practical scenario of M1 profile slide?
Come on, tell me.
Sir, in this before the wear, the flow is subcritical, no, sir?
Yeah, obviously.
On the wear, can we say that is supercritical because the length, the depth of the flow will be some very less
Where?
on the wear. If you extend the flow line.
That's not about depth. You can. I understood you. Whatever you are saying is this one. Yes.
Yes, sir. Yes, sir.
No, it's not going to be like that. You cannot analyze that. See, that's a hydraulic structure. This control section.
Yes, sir.
We have to analyze either upstream or downstream. We cannot do anything on the weir or barrage. Okay.
Okay, sir. Means what we will consider this, sir? Means we
Just
directly
type of flow, subcritical flow only, and from here onwards it is going to be changes and changes and changes and changes and comes as supercritical flow over here. Okay. Somewhere there must be serial. Na? See, you see, this is serial, right?
yes, sir.
Above here subcritical, below is going to be supercritical.
Okay, sir. We will directly. But if it is, we consider hydraulic jump on that line only, no, sir? Then.
Now outside means once it falls on the foot of the spillway.
Okay, sir.
After the falling on the foot of the spillway, then only you have to consider.
Okay, sir. Okay.
Yeah. Okay.
Thank you, sir. Yes.
Yeah. Mr. Karthik, please speak out.
Hello.
Yeah, Karthik, tell me.
Good afternoon, sir.
Good afternoon.
Sir, in S0, slope is rising. Then you told that y is equal to infinity now, sir.
Yes.
means that means water is storing there.
Yes.
Sir, means is it a reservoir like a dam like structure?
That's what the way there only you're going to see. For storage purpose means reservoir.
Means sir, before water is getting into the dam, means the slope should be rising. We should provide the slope as rising. Sir.
Yeah. Yes, yes, yes.
Okay, sir. Sir, another one doubt was there.
Mm.
Although it is not in our syllabus, I think, sir. We have learned that channel drop or rise will cause the depth of the water more or less, no, sir. Sir,
Yes.
if the channel is having curves, then there is also possibility to rise or fall.
That's meandering.
Oh, okay, sir.
That's channel transition meandering that we don't discuss. Okay.
Ah, sir. Okay, sir.
Definitely due to that meandering, the curvature will change.
Okay, sir. Okay, sir.
Yeah.
Thank you.
Okay. So that's all for today's, and we'll be meeting.
Hello, sir.
Hello.
Sir, this is Pranjal Padole, sir. The first one, my network.
Yeah, Pranjal, tell me.
Yeah, sir. So that same doubt, sir. I wasn't able to hear you. What would be the case in steeper section, sir?
Yeah. See, in the case of the steeper section, what happens is the water level will fall and meets NDL asymptotically. Yes or no?
Okay. Sir, can you please show that diagram? It will be easier to understand.
For example, you see,
Huh?
this is steep.
Yes, sir.
This is CDL.
Yes.
This is NDL.
Okay, sir.
So if the flow is falling perpendicular to CDL and asymptotic to NDL, yes or no?
Yes.
But this is a drop or not?
Yes, sir.
When it is a drop, do you think the water falls like this? You see the curvature, it comes and falls like this? Possible? Tell me.
No, sir.
Which one is going to be practically possible? This portion or means A or B? Tell me.
Yeah, A, sir. A1 is practical.
That's the reason why.
Sir, and
See,
one more,
generally
sir.
we provide, I'm saying though, in
Okay.
practice, generally, when you are going to provide the drop now,
Yes.
you make sure the slope is going to be lesser slope or flat slope. You are not
Okay.
going to provide a drop for the steeper slopes.
Okay, sir. Got.
Yeah.
Sir, and one more, sir. I came across. I did not got the meaning of the question, sir. That is, the downstream end of a long prismatic channel of a mild slope ends into a pool created by a dam.
That's what M1 profile, M2 profile.
So what does it mean? Ends into a pool means?
I don't get you. You please tell me once again.
Yes, sir. The downstream end of a long prismatic channel of a mild slope ends into
Okay.
a pool created by a dam.
Ends into a pool created by a dam means M1 profile.
Sir, visually I can't like access that. How it is?
Visual, that's what you see. I'm going to show you that.
Yes.
See, this is a mild channel.
Yes, sir.
This is a mild channel.
Yes.
Created by whom?
Where, sir?
We are dam. On the
Yes.
water level has been raised or not?
Yes.
There is a long channel on the downstream side. See, for this mild, this is upstream side and this is downstream side. Okay.
Yes, sir.
So this long channel has been ended by a weir or barrage, so that the water level is going to be rises.
Okay, sir. This is what the pool created by dam. Then,
Yeah.
whatever.
Yes.
Okay.
Okay.
Yes. Okay, sir. I got it.
Yeah. So okay, fine. For that.
Yes, sir. Thank you, sir.
Yeah. Thank you. So for the remaining things, if you have any other doubts, you know where to contact me. So we'll meet tomorrow morning.